Okay, welcome. We're going to get started. Welcome to today's workshop, Use AI to Build and Share Insights from Health Data, brought to you by the R Consortium. The R Consortium supports key organizations developing R infrastructure through grants and sponsorships worldwide. Please visit our website to learn all the details and how your organization can become a member. I'm Jesse Kasman. I'll be in the background. Garrett and also Sarah will be doing the workshop. I just would like to make a quick comment on encouraging you to come to the R Consortium website and check out. We hold events like this regularly, and these are all the webinars, the workshops, and more are listed on the R Consortium website. Okay. Garrett, I believe you have introduction as part of your workshop, and so I'm going to turn it over to you two, and we'll get started.
Thanks, Jesse. And hello, everybody. My name is Garrett Grolemund, and I'm joined here by Sarah Altman, and I'll put our faces up on the slides in a minute. But I just also want to tell everyone that we are recording this, and I just want to emphasize that. So if you have colleagues who can't attend today or make it today but might be interested, the recording will be available from the R in Medicine website. Now, with that said, let me make this a more visual experience. This is a workshop. We can think of it as a use AI to build and share insights from health data. We're going to look at ways that you can use AI to do the sort of things that I suspect you do with data. And let's keep letting people come in as we do this. Sorry. My name is Garrett. I am an educator at Posit PBC, which is a company formerly known as R Studio. I made the Lubridate package, and I'm a co-author of the R for Data Science book. And for over a decade now, I've been teaching people how to use R packages and open source software, and even a little bit of Python to do things that data scientists do. And those things have changed over the past decade. Today, we're going to learn one of the most recent and earth-shaking changes, which is using artificial intelligence to analyze data. I'm joined today by Sarah Altman, my colleague at R Studio, or at Posit. And Sarah, why don't I turn the floor over to you and let you say a little bit about yourself, and we'll go from there.
Yeah, hi, I'm Sarah. I'm just going to be helping Garrett with the workshop today. I'm on the AI team at Posit. I'm a developer advocate, mostly work on Posit Assistant, which I think we'll talk about later in the workshop.
Yeah. And Sarah is at the forefront of all things AI and data science, and she's a regular contributor to the Posit blog where she writes about AI topics. So if that's an area that interests you, do check out posit.co, maybe /blog. I actually don't know. I just Google it. But we publish our ideas there pretty often. Another facet this brings up is this is a Zoom meeting, and there is a chat window there. And there probably will be a lot of participants here by the end of the workshop. But if you get stuck up with technical trouble, or you're curious about something, you have a question, put it in the chat, and between Sarah and myself, one of us will likely see it and be able to respond to you. And if it's an interesting thing or a whole group sort of thing, we could even surface it into the discussion and bring it into the workshop. So do use that chat. I can't promise that I'll always be up to date on the chat as I'm presenting, but we will be paying attention to what you put there. All right. So here's what I propose we try to do today. I have a data set for us to analyze. It's about incident rates of different types of cancer in the state of Georgia. I was recently at a conference in Georgia, so I pulled up that state, and it's simulated data, so that, there's no HIPAA violations or anything. Some of the relationships in here will reflect the real world, and other ones will be artifacts from the simulation process. But we can use this data as a MacGuffin to learn about different things we could do with AI to make this data accessible. The data set looks exactly like this. There's various groups created by combinations of different demographic variables and location, what county in Georgia they're in. And then the number of cases of a particular type of cancer, that shows up as a site variable, the site in your body that's experiencing cancer. And then the total number of people in that group, so we could calculate a rate. that'll all become clear later, or actually it doesn't matter if it's all that clear. But what we're going to try to do with this data is create something that looks like this. So this is an interactive app. We'll each make our own copy by the end of today. It has a map where we could look for hotspots of cancer incidences in Georgia, but it also has on the sidebar here a chatbot. We could chat with this app, and it's powered by AI. There's a large language model here that will respond to our queries and update the data and help us explore the data. This is an app that we will build with R today, but is a Shiny app. And if you're not familiar with Shiny, that's a way to use R to make web apps that non-R users can use by visiting them through their web browser. So if you can make an app like this, you could host it somewhere, and all your colleagues or the doctors at your institution, where they could come here and explore the data, and they never have to write a line of code. And it looks like you probably invested a budget of $100,000 to make this, but I mean, we're going to make it this afternoon, so you'll see what that's like. Now, I want to say a little bit about where I'm coming from. Sarah and I both work at a company called Posit. It was formerly known as R Studio, and it's a fairly unique company in that we make tools for the R ecosystem and also tools for companies that use data scientists who use R. We're a public benefit corporation, which means we have a charter that includes a mission to the public, which in our case is to create free and open source software for data scientists, scientific research, and technical communication, which we take very seriously. And we are a member of the Open Source Pledge. Our business model reflects the tools that I was able to provide for us today. So Posit creates free and open source software. I mentioned earlier, I made the Lubridate package. My colleagues made the rest of the Tidyverse. We made all that, and it's free, and that's really what we want to be doing. But we have to pay the bills. So we make software for scientists, and then companies that rely on those scientists, they spend a lot of money just to get teams to work together efficiently. That has nothing to do with free and open source software, but if those teams are using free and open source software, they will pay for tools that help them use that software efficiently, securely, collaboratively. And that's what Posit also creates. And we sell that to the companies that value from it. And then we reinvest that money in more free and open source software. And we think of this as a virtuous cycle. How does that matter to us today? What we're going to use today is all free and open source. Every R package, QueryChat, Shiny, these things that we're using, it's all free and open source. And you could download it on your desktop. If you're a grad student, you have access to it. And we're going to be editing it in a code editor that is also free and open source, and you can download locally. But in some ways, we're like a company. We're a large team of people here, and we're all trying to get the same experience and work in the same environment, have the same packages preloaded and stuff. So we're going to use this free stuff on one of our open source, well, not open source, our professional products. This is what Posit's professional suite looks like. We have 3 products, and what we're going to see today is we're going to use a product called Workbench, which creates secure, scalable compute sessions. We'll all log into it, and that's where we'll write our code. And it'll be pre-provisioned with everything we need. And then once we make something that you might want to share with the world, we'll share it on Connect, which is our product for deploying data science artifacts like Quarto reports, Streamlit apps, Shiny apps, anything that you can make in R and Python, you can deploy to Connect. And Connect can run R and Python code, so it can maintain those products for you. So that's where we'll be headed. And now you know quite a bit about me and Sarah. I would like to know a bit about you. So this is a Zoom meeting. I'm sharing my screen. And if you look around, you should be able to spot an annotation feature in Zoom. I think we all have permission to annotate. This will be like sort of a proof of concept. It normally looks like a green pencil. Find it, click on it, and then I want you to use that pencil to draw on your screen to circle where it says circle me. Very good. Okay, we will use this. I see not all the circles are on target, so I don't know if there's some weirdness here, but I think this will work. Okay, so now second proof, I need to make sure I can erase all this. And it looks like I can. Okay, so that's good. All right, you don't have to circle that anymore. Get ready to use that tool. So let's go forward a slide. Oh, that'll be a little annoying for me. All right. What I would like to know from you is which code editors do you have experience using? So use that annotation tool to circle any of these. You can circle more than one if you've used more than one, but I just want to see what people are familiar with. Okay. Huh, that's interesting. I mean, this is pretty much what I expect. Like, this is R in medicine. A lot of people have been using our studio. Some people seems like I've heard of and use Positron. We'll use Positron today. I'll tell you why later. And then I see a lot of VS Code use. I don't have an easy way to follow up, but I am curious to know if anyone's using VS Code for R or if that is predominantly like Python users or people use other languages. All right. Let's go forward one slide. Let me clear this stuff. Boom. All right. Let's try this out. I'm going to now give you a server that you can use for the rest of the workshop. Actually, I can't tell easily at the moment how many people are here. 124 people. I think this is going to work just fine. But this is how we're going to do it. I want you to go to workshop.posit.team, and I'll go there with you and we'll look at it together. If you wanted to, you could download the desktop version of Positron and follow along with us. You just have to install R packages as we go through the workshop. But I don't think that's going to work out very smoothly. So let's try doing this together. Go to workshop.posit.team. You'll see a page like this. This is an online instance of the 3 products I just showed you. And we're going to use the Workbench product. So when you see this page, click on Posit Workbench. And then where it says sign in with OpenID, click sign in. We're going to try to sign into Workbench. This is an instance of Workbench hosted on a server in the cloud that Posit maintains. And none of us have an account to it. Actually, Sarah and I do. But what we should all do is find the register button at the bottom of this page and click it. When you click register, it'll give you this form and fill it out. You're going to create an account for this server. You can fill in whatever information you want. I think the email has to look like an email, but remember this information because we're going to have to use the same information when we log in to connect in the second part of the workshop, okay? So I'm going to choose a username for myself, password. You do all the same things. And then once you fill this out, click register. Prepare for a moment of unconfidence, but do fill it out and click register. Oh, that's not exactly what I expected. All right. If you've seen a sign that says we are sorry and you can't get in, unfortunately, that's been happening quite a bit. Don't worry. Just go backwards to the login page, but this time log in with the account you just made. If you see what I see, that's a bit new, and I'm going to try to sign in again. All right. And now I'd just like to ask people in the chat, did anyone sign in successfully? If so, let us know. All right. And did anyone see a different screen than I saw? Maybe one that's still grayish black or something. Slowly. Loading. All right. Let me Sarah, if you can go to the PTD workshop team and let them know that the workshop started and things are so much slower than they were yesterday, they might be able to do something on their end, but we'll keep going on the front end here.
Okay.
So I'm going to stop this. I'm going to go back to workshop.posit.team. So I'm going to restart my process, and that's what I encourage you to do as well. All right. Well, if you have access, try to log in. If not, while we're waiting for this all to work, let's go back to the slides. We'll come back here, we'll get that. First, I want to tell you about Positron, which is the code editor that we're going to use today. It seems like many people have the RStudio background. That's my original background. I love RStudio. If you haven't heard of RStudio, it is a code editor designed for data scientists. Most code editors are designed for software engineers. All of us use code, but we use it in different ways. And what is unique about the RStudio IDE is it has tools that data scientists use every time they do their work that software engineers don't really use and therefore don't care about, because of which you don't always find in a code editor designed for software engineers. But we made it about 15 years ago and is really tied in with the R language. And even though you can use Python in it in different ways, it's just not really what you'd call a multilingual code editor. I saw some people said that they use Visual Studio Code. And if you haven't heard of Visual Studio Code, it's probably the state-of-the-art code editor for software engineers, used by millions of software engineers every day. It's not that old. It was created fairly recently. And it's designed to be multilingual. It's, if you're writing code in any language, it will help you do it. So it's not tied to something like R. And then it's created by Microsoft, and they've open sourced it. So they do have a paid version, but there's an open source version that is free to the world. And we liked a lot of what's going on in Visual Studio Code. So we took that open source version and we added in what we felt were the missing data science tools. And we did a lot of work to make a really first-class experience for data scientists using R and Python and increasingly SQL. And we call this new fork of Visual Studio Code Positron. And that's what we're going to use today for a couple of reasons. But the main reason is Visual Studio Code being fairly recent development, created in the age of AI. It's really easy for us to build out and test AI features in Positron. And when we get into this server, we'll be able to use those features. Those features will all come to RStudio. RStudio is not going away, and we're dedicated to bringing things there. But it takes a lot more engineering work and coding to retrofit such an old IDE with the modern AI features. So today, we're going to try out Positron. I'm just going to check in, see what's happening here. Sign in with OpenID. Well, still quite slow. Ridiculous, really. All right, so Positron will look like this. I'll give you a tour of it once we're inside of it. But what I'd like to do right now is ask you a little bit more about your R knowledge. One theme of today's workshop that I really want to stress is, in the age of AI, code-first programming makes more sense than it ever did. With just a little bit of investment in understanding a coding language like R, you can now do so much and go so much further, so much faster than it was ever possible before. So let's just look at the rudiments of R that we're going to use today. If you're new to R, or if you know of someone who is new to R who might benefit from this, have them watch the recording and let's see how easy it is. The rest of us will just, have everything at our fingertips as we go through the workshop. So my first task for you, let me know which languages you have a background in. So just like before, circle all the ones that you've used or you feel comfortable using, and I'll know what to reference. And then if you circle other, that's really curious, type in the chat and tell us what languages you're talking about. Julia, SQL, yeah. SAS, SQL. All right, so we have a lot of other, and that seems to be like a potpourri of different things. But I do see SAS, and I see SQL, and Julia, and SPSS, and even MATLAB. So the things that you'd expect, maybe the things that you've heard of in grad school or something. And then I'm also checking in on this situation in the background for us. All right, and then lots of R. Okay, so let's continue. Let me get my eraser handy. All right, I know everyone knows this, but just practice. What would 1 + 1 return in R? You could circle the answer. 2. Thanks, Kari, for being the first. Yeah. So if you're completely bewildered by coding languages, just think of R as a calculator. It can do math. We can start there. We all do math. All right. So now if I clear all those drawings, go to the next slide. I guess I should have left them up so we could see if we had the right answer. How about this? ABS -4. For those of you who don't know, ABS is short for absolute value. Okay, yeah. So if you ran this piece of code, it would be telling R to take the absolute value of -4, which is 4. So all of these answers here are correct. And I did. Ta-da, you get it right. That's simple, but this is important. This is the skeleton of R. R is made from functions. So just like a fancy calculator, like a TI-89 calculator or something, there's some things it's easy to type out to do the math with, but there's some mathematical operations that they provide functions that let you do it. R does that as well. You will use functions to do things. And here's some examples of some lightweight mathematical functions, but there's no limit to the type of functions that you'll see in R. They might make plots. They might download things from the internet. They might do more than just math, but functions are in R. All right, let's go forward. How about this? If you ran this code, what would it return? Very good. So what we see in this line of code is we are saving the number 4 to num, and that's creating what I'll call an object. And then every time we reference that object, no matter where or how we reference it, R can look it up and find the value that we stored in it. In this case, that would be the value of 4. And then getting good at this. All right. You could pass objects to functions. Square root would be able to look up num and find out that it is 4, and the answer would be 2. You know, if the screen's not gray, you don't really have to circle anything, but you could also take the output of a function and save that in an object. So these objects are like algebra. It's like we could just store things in random symbols and use them to make our life easier. And that is something you'll see again and again through the code today. Things like when we read in a data file, reading is a function, we're passing it the name of a file, and then we're saving that as an object, and it's called data. When we join together data sets, same pattern. We'll be using this pattern throughout the day. All right. So we have functions, we have objects. I would say there's only really one other thing you need to know to get started with everything we're going to do today, which includes building Shiny apps. And that is this. What does this do? And I guess I should erase those other responses. All right, what does this do? Yeah. All right. So we have the R experts leading the way here. That symbol there looks like a straight line and then a greater than symbol. It's called a pipe, and it does something specific. It will take whatever's on the right-hand side of it and pass it as the first input for the function on the left-hand side of it. So when you type that out, that's the equivalent of telling R to take the absolute value of num. And that might seem weird, but actually it creates a lot of advantages for us. One advantage is you could then immediately pass that into the second thing. And so you could build up this sequence of pipes. So this here, clear the drawings out, would be the equivalent, right? Take the square root of the absolute value of num. And we can also break that up over several lines to make it even easier to read. So now this is the same thing. And at the end of the day, it's still taking the square root of the absolute value of num. But now we have num, and then we take the absolute value and have square root. And we can make this go on for many, many lines with more and more pipes if we want to. And what you'll see in R and in the code today is that we use this, and it creates a very readable style of coding. You'll see this as a pattern where basically you're going to create an object, I'm calling it result here, and then you'll have a recipe that explains where that object came from. You're going to start with this input object, then you're going to do this, whatever that function is, and then you're going to do that, the next function, and then you're going to do the third function. And it's just laying out the steps for building this thing. This is what R is all about, and I think it makes R one of the most user-friendly programming languages out there, especially if you're working in statistics or data science. All right. All right, so let's add that to our sheet. Those are the three things that matter to us today and will matter to you as an R user. Everything else is essentially just elaborating upon one of those things, normally the first two things. There are two elaborations or three elaborations that you might want to have in your back pocket as we go forward. So more interactivity. Does anyone know what this would return if you did the question mark of abs? Beautiful, yeah. This is how you open a help page. So there are many functions in R, and you won't know what they all do or how they all work. But for any function, you could type a question mark in its name, and R will open a help page where you could read about that function and how to use it. So that's great. And then how about this? Abs -4, but we put a hashtag in front of it. What would that return? Perfect. All right, so that's going to return nothing. The hashtag tells R to ignore everything on that line that happens after the hashtag. Normally, you might do this in front of a function if you want to try running your code without that function getting run. Maybe you're debugging. But it also creates a great opportunity to just type notes into your code files. R won't try to run them. They'll just be invisible to R, but humans can read it. And that gives you an opportunity to maybe explain what your file's doing. So I'm going to clear these drawings and show you what that could look like. Maybe when you create these things, you start with a comment with a hashtag that says what you're doing. All right. And then one last thing, it's going to show up when we get to Shiny. So we should know about it now. That is this. So I'm creating an object. I'm passing to it this list thing that's putting together these three objects, and then I'm calling this syntax. Do people know what this will return? Yeah. So if this is unfamiliar to you, follow the logic here with me. You can store anything you want in an object, and it's very common to want to store things together because they relate to each other somehow. And the most common way to do that in R is to create a list. And then in this list, I'm storing the value 1, 3, and abs. And then it's good practice to name those things so you could access them later. So here I'm storing 1 as under the name A, 3 under the name B, and the function absolute value under the name C. If you use that name, then you could use this list name, $element name syntax to get that particular value out. This is again the 3 value. All right. So we'll use that later. I normally don't like to lead with that, but there's so many R users here. I don't think it's going to be trouble. All right. Good job, everyone who put a circle there. Yes, clear all drawings. Boom, boom. All right, so this is our complete R checklist. If you were brand new to R today, if you could keep these things in mind, you will be okay. All right. One last thing to know about R, doesn't make a good interactive exercise, but the beauty of R is people can create new functions for you to use, and they could share those, and they do. And they share them as packages. So packages are groups of functions and data sets that you can download to use in your R sessions. They don't come with R, but you can download them. And the way you download them is with this install.packages command. Once you download it, it lives on your computer. So you only have to do that once or when you want to update that package. But then every time you want to use it in an R session, you first have to use the library command to sort of like pull that package out from your library and put it on the table so you can start using it as parts. So you'll see library commands, and they're just telling R, we're going to use the functions in these packages. All right. Let's pause there and go back to workshop.posit.team. Okay, I'm in. It worked. If you registered for an account, when you click register, it should bring you to this screen. Sometimes it brings you to a screen that says, I'm sorry, I don't know who you are. I'm not going to let you in. And that's just because we have so many people creating accounts at the same time that it brings us to the screen before it finishes processing those new accounts. And if you got that screen, you just need to do it again, but this time just log in with the information you made and that'll let you in. If you got the white screen that I got or no server available, I don't know what caused that except that our server was not working, but it looks like now it is working. So if you're not in, let's go through the process together again. If you are in, stay here, okay? But if you're not in, go to workshop.posit.team. Team. It'll take you here. Click Workbench. I'm already logged in. And then I really don't want to log out at this point. If you're not logged in, you'll see a screen and it says sign in with OpenID or something like that. Click yes, sign in. That will take you to a screen with a sign in page. If you've already registered an account, which you probably have, just put that information there in the sign in and click sign in. And it should take you here. If you never got a chance to register an account, I don't think anyone's in that boat, but go down to the bottom of the screen where it says register, click that button and just fill out the form and then click sign in. In either case, it should take you here. So can I see in the chat if anyone is having trouble getting to here, who means to get here? All right, so people are here. That's good. Okay, good. Well, then we could get started. So this is what Workbench looks like. It keeps track of all the different times you log in and the projects you're working on. This is our first time here, so there's nothing to keep track of. It's empty. What we want to do is click New Session. It's going to be an important detail here, so follow along with me. Click New Session, and then you'll see at the top you could select which IDE you want to use. Don't change that. We want to use Positron Pro. Then we could like sign into Amazon stuff, but we don't have any credentials there, so don't bother with that. What we do need to do is go to the image here in environment. There's several images. They each have different sets of packages installed because different people are using this to teach different workshops. The set that we need today is the very last set. That's right. It's the one that ends in A112A. And I don't think I could copy and paste that into the chat, but what you want to do is select this, select the very last one. And then once you're sure that's checked, click launch. If you choose a different image, you won't have access to all the packages we'll use today. You can install them yourself, but it'll be quite inconvenient. So choose the last image, ends in A112A, and then click launch. All right, so now what's happening is Workbench is spinning up a session for us. It's provisioning it with an IDE and the different compute resources we're going to need to write code. And this, on a good day, takes about 30 seconds to 60 seconds. We'll see what happens right now when we all hit it at the same time, but I don't anticipate it taking longer than 60 seconds. We'll just wait and see. All right. So I could see that it's starting a session because it is giving me updates here, and you should see something like this too, hopefully. Now, I do imagine with a large group, for some people, after 60 seconds or after however long it takes the rest of us to get in, it's going to be still run. And I've noticed sometimes it seems like, I don't know, something goes wrong. If it's running on forever, it's best to hit cancel and then just start again. And the next time it goes faster. I think something about talking to the different servers, sometimes messages get lost or something. Since this one says it's starting, I'm going to wait it out. Okay, now it says active. And now I'm in. Okay, so over the next few seconds, hopefully this will happen for you as well. You'll get in, and now you're really ready to start writing code. Let's give people time for that. All right, and then I would say if you started it around the time I did and it's still running, now we're in the territory where you should hit cancel and just click new session again. See if the next one goes a little faster. I'm going to just pop in and take a look at the chat. Just see what do you do after it says active? You just keep waiting, John. It's almost like a progress bar as it cycles through the states, and then it will open on its own. And if you start with the wrong image, you could just cancel that and click new session and pick the right image. But if you've made it all the way in like this and you're on the wrong image, Down here where it says Posit Workbench, you could click that to go back to where you were. So if I click that, I'm here, and then I could click New Session. Now it's a white button, but then I could pick, my image down there. Since I already have the session going, I'm just going to hop back into it. All right. Now that we're in Positron, let me give you a tour of it because it looks like, a sizable minority of us have used it, but not everybody. It is new as of last July, so it's almost a year old, but really that is quite new, and it's been in active development since then, so there's a lot of changes happening. What you see when you first come to Positron is something that looks like this. Unlike RStudio, it doesn't use the idea of R project files or anything like that. It's very much like R itself in that it uses almost a working directory to organize your work for the day. And so the first thing that we're going to have to do whenever we come to Positron is tell it which directory to work out of that day. In fact, once we select a directory, it will become the working directory for the R session inside of Positron. But it's also where Positron will save files to and open files to if you don't ask it to do something different. So here it is. It's asking us to open a folder in several different ways. I've prepared a folder of material for us to use in the class, and it lives on GitHub. So instead of just opening an existing folder on the server, of which there's not many, I want us to open a folder from Git. And the way to do that is to click New from Git here, or you could click Clone Repository here. They both come to the same destination, but the UI is a little better, I think, if you click New from Git. It takes you to this window, and you just have to paste in the URL of a Git repo. And I have that Git repo right here. By the way, you're welcome to visit this outside the workshop and look at all the scripts and stuff we're using today. I'm pasting it into the chat. And what I'd like you to do is copy and paste that into the window that we just opened. So where it says new folder from Git, it opens this window. Just copy and paste that URL here. Don't change anything else. Don't click open in a new window. Just click OK. It'll download our contents and it'll refresh Positron. All right, here we are. Positron's loading a Python session. And let me give you a tour now that I have some contents to show you. Instead of asking us to open a folder in the sidebar, now it shows us the contents of our folder. So we're in a folder called AI Powered App Workshop /Healthcare. I know it's a long name. And in that folder, there's some other folders and there's some files. For example, I have a R script called helpers.r. And if I open that R script or any other script, it's going to open right here, front and center in my IDE. And this is where I could write this file, edit it, save it, run code from the script. If I wanted to run the script, I press the play button. I don't recommend you guys doing too much yet because we're going to do a bunch in the workshop. But that's where our script's open. If I wanted to run R code itself, I have a console down here that's running R. Today it's running version 4.5.0. And I could do something like histar norm 100. And if that code I run makes a plot, the plot will appear over here in the dedicated plots pane. If it creates an object, like I'm just going to make an object named A, the object will appear over here, my variables tracker. And this is all just like the RStudio IDE. In fact, these 4 panes are fairly similar to the 4-pane data science experience you'll get in the RStudio IDE, with a few exceptions. The file browser is obviously over here in this new sidebar. It's not by the plots window. We could change what's in this sidebar by clicking on the different items in the blue strip here. Some of the items have been collapsed because there's so many. But if I go to the 3 dots, I could see there's a packages item. That's where I view the packages have been installed. So that's in a new place compared to RStudio. And the green means it's been loaded. Open circle means I haven't loaded it yet. It's a little different interface, but the idea is the same as a package viewer. The coolest thing here, if I go back, if you ever want to see your files again, you come back up to the first icon. It looks like 2 files. That takes you to the Files Explorer. I don't have CSVs and real tables of data to look at here, but I do have an RDS file, which is an R format for saving data. And if I click on it, Positron wants to show me it, but it realizes I have to load it in R, so it gives me this option to load it. So I'm just going to load it. You don't have to do this. I just want to show you our data explorer before we get into the content. So now that it loaded it, it appears in my variables pane, and I could look at the different columns and things the way I probably would in RStudio. But I also have the option to open it in the Data Explorer, which is where most of my analysis in Positron start. This is the Data Explorer. It shows me the raw values of that data set. It's terribly hard to see. I don't have much screen real estate focused on it yet. That brings me to like one of the most practical tips for Positron. Over here in the corner, there's these three buttons. They're very simple and very useful. All they do is they hide part of the IDE and bring it back. And since so much is going on, it could be pretty great to hide some of the IDE. So here I've hid everything except the data viewer. Now I can look at this Georgia cases data set, see the raw values. This is the values get lazily loaded as I scroll, which means this is an infinite scroll, but this is not an infinite data set. Although I'm not going to get to 96,000 rows anytime soon. I could sort the data based on values, ascending or descending in any column. I could filter based on values in any column. I could pin any column if I had a lot of columns. I was scrolling vertically, horizontally. But the coolest thing about this is it comes with its own sidebar, and it shows me every column in the data set, as well as a histogram of the values in that column. And if I open any of these up, I could see that distribution. If it's a numerical value, I can see the summary statistics for it. And then for every column, I can see the percent of missing values in that column right off the bat. So this is a really quick visual way to get to know your data. All right. What you'll need to know about Positron to do the next section is pretty easy. We're going to bring back the rest of the IDE. We're going to want to open a script, and it's going to appear here. And if you have a script and you want to run a line in that script, you could put your cursor on the line and hit Command Return or Control Enter, depending on Windows or Mac, and it will run that line of code down below. And you could do that to go through every line in your file. Or you could click the play button and it will source the file, which means it'll run all the lines at once. In both cases, they'll be run down here in your R console. And I'd be terribly amiss if I didn't cover one more thing before we left this, and that is, even though we're using R down here in the console, you can see I do also have a Python session I could use. I also have a terminal window I could jump to run things like pip install or bash commands. And if I'm not satisfied with either of these versions of R or Python, I could ask for a new console, start another, and Positron will scan my server or my local machine to see which language interpreters I have available, and I could use any of those for my session. So if I want to, I could open an older version of R and run all my code in that, maybe because I'm writing something for someone who uses an older version of R, or I just want to see if it's backwards compatible or whatnot. So I can have multiple languages open and multiple versions of a language in my session. If any of these consoles crash because I did something crazy, it wouldn't affect the rest of Positron. I just trash that session. I'm going to trash the Python one right now. And then, open a new console or proceed with what else I have. All right. That was a lot. Let's take a look at a script with our code inside of Positron. What I'd like you to do is find in that sidebar miscellaneous.r or misc.r. Open it. It's the file I was just looking at, and run each line of R code. If you're new to R, try to anticipate what it does based on what we just reviewed, but see what they do, because we're going to use this code over and over again today. Now, the last line of code does return an error. That's on purpose, so don't worry about that. I'll start the timer. While people are working on exercises, it's a great time to ask questions in the chat or seek help in the chat. I'll try to catch up and provide that help.
Garrett, do you have a shareable version of the slides? Or were you planning on sharing slides?
I do not have a shareable version of the slides. I was tempted to put in the Git repository, but that would make the download a little too big.
Yeah.
But I can work with Jesse to see if there might be a way to share the slides along with the recording when that's available in a couple of days.
Great.
And then Jonathan, I do see your error message in the chat, and that is expected. Stephen, that one is less expected. But you would get that if you maybe ran the lines of code in the file out of order. If you run the line that says source helpers.r first, then the line that includes create instance map should work. All right, so we're at the 30-second warning. So I'm going to move over to Positron and catch up with everyone. So I have the file open, and I'm going to run all these library commands at once. Okay, Michael. Some of you might be getting errors at this stage that say, I don't have those packages. And that means you have the wrong image installed, and you have two options. The first option is to start installing those packages, but SF and Tidyverse can take a while to install with installed packages, so I don't recommend that. The second option is to click on Posit Workbench down here, which will take you back to Workbench. And then click New Session. You just go start a new session with the new image. When you get the new session, in this image chooser, choose the bottom image. It's the one that ends in A112A. And that image will have those packages already installed for you. So if you don't have the packages, come back and make a new session with that last image. And then Nell, Charles Nell, what's the appeal for a hardcore RStudio user? That's a really good question. The appeal is mostly access to the AI features we'll be going to, perhaps earlier than you get them in RStudio, and that multilingual way of doing things. Other than that, if we find something that works really great, like this Data Explorer that we built for Positron, we do want to move that into RStudio, and that Data Explorer, for example, is coming into RStudio. And you can expect everything else too as well. RStudio is not going away, but it will probably always be an IDE that's very focused on a single language, the R language. Who can share the link for the workshop? I'm not sure. Those of you who have trouble again to get repo URL, that's probably a character encoding thing based on how you're copying out of Zoom. I don't know. But the suggestion from Jennifer is a great one. Paste the link into your web browser and then recopy it from your web browser into Positron, and that should clear it up. Okay, so I ran the packages. Let's get back over here to R. I'm going to load this data set. I'm going to source this helpers file. Helpers is a file over here that defines a function or two, including the create instance map function, which we're going to use next. So I'm going to create instance map with Georgia cases. That's the function we'll use to make this beautiful plot. I'm going to run the data tables line. That makes a beautiful table. So it does take a second. And then plot instance by demographic returns an error. And the reason it returns that error is over here in helpers.r, I created a few functions and I documented them really well, but I forgot to write the second function. It's only documented. That function's supposed to be plot instant map or whatever. This gives us a chance to put AI to work. So let's learn about AI and we'll use it to make this missing function. So before we move to AI, what did we figure out? Well, R is built on functions, objects, and pipes. So like typical R code, you'll see some functions come in packages. All right. We use Positron. Now we're going to use AI in Positron. So the great thing about using this server, even though it was a struggle to get onto it, it's pre-configured with an LLM model provider. So we can just use AI. It's all set up. And the way you use AI in Positron is through something called Posit Assistant. When it appears in the sidebar, it looks like these two diamonds that are overlapping. In our case, it's kind of hidden by 3 dots, but we'll get there in a second. It's not a large language model, so this isn't like if you use some product like Jira and they provide their own Rovo form of AI or not. We don't provide our own form of AI. We make it so you could use the models that your company has approval to use or has granted you approval to use inside of Positron. So the first thing you do when you come to Positron is sign in to your model provider, whether that's Amazon Bedrock or GitHub Copilot or Gemini or OpenAI or whatever you're using. If it's a common model provider, you'll be able to log into it through Positron. And then whenever you ask AI to do something, Positron will be collecting your query and sending it to your account at that model provider. Their model will answer and provide a response that will bring back into Positron. But there's some benefits to this relationship. And the first is, if you used any large language model and asked it to help you with your R session, that R session or your Python session will be a black box to the model. It will not know what's happening inside there unless you find a way to tell it. And that can create a lot of speed bumps as you work back and forth to write code or analyze data with something that just doesn't have access to the place where all your work is unfolding. Posit Assistant will bring your model into your R session, into your Python session, into your Positron session. So it could see everything that you can see, and it can write code that just works, and it could debug things because it can look around and see what's just not working, and everything will go faster with no speed bumps. So it's a productivity boost. The other thing is, as we bring your model into Positron, we're going to upskill it by teaching it how to write R code, Python code, build Shiny apps, Quarto reports, the sort of things that people are going to be doing inside of Positron. We teach the models how to do so they can help do them better than they would out of the box. All right, so let's come over to Positron. Let's take a look at this. Like I said, some of our icons here are just getting caught in the last 3 dots. And your Posit Assistant may be in there. Mine's actually showing right now, right here. If you see this symbol, click it. That will open Posit Assistant. But if you don't see it, go to the 3 dots and select Posit Assistant. It will open in the sidebar over here. You see it's a little bit of a chat bot. And it's already set up for you to use. But to Michael's question, if you came here the first time and it wasn't set up, you would see a big blue button that says, help me set up a model provider. And when you click it, it would take you to this window, the window you find in the Configure LLM Providers menu here. And it's the one from the slide. What options you have here depend on how your IT team sets up Positron if you're working through Workbench. But the model that you have approval to use would be in that list. And then you click it, and you could, if I want to sign Amazon Bedrock, I'm already signed in, so I could click sign out. Don't do that. That'd be kind of silly to do. If I wanted to sign into Anthropic, Claude's models, if I had an API key, I could paste it in there. I could sign in. It'd check to see I have an account. It'd link me up to that account. And then those Anthropic models would be available as I use Positron Assistant. Same with GitHub Copilot, OpenAI. How you sign into different model providers changes from model provider to model provider, but the idea is we're just opening up their authentication process, and you authenticate in, and then you're connected to your account. Since I am connected to Amazon Bedrock, and so are you, we can talk to Posit Assistant, and it'll use the Bedrock models. And Amazon Bedrock does provide Claude models. In fact, here's all the models this account provides, and we could toggle between them as we do our work. The default 4.6 will be more than sufficient for us today. There's some features to Positron Assistant we don't need to rely on too much for what we're about to do, but this light bulb here lets you set a thinking mode, like how hard do you want to think about what you ask it to do before it does it. Medium's just fine. Low would be fine for us probably. There's a specific data cleaning mode. If you want it to ask it to clean some data, you could use this mode, and it will clean your data and save the output as a script for you. That's really interesting, but we're not going to get into it today. And then there's a plan mode, which is, I don't know why it's not plan mode. Oh, I want to turn, I'll make sure I'm not in data cleaning mode. And plan mode is a typical plan mode that you get with all AI. Let's use it to write this function. And here's how I want us to go about it. I have a prompt. You could write your own prompt, or you can use this prompt. It's up to you. I'm going to paste it into the chat so you could paste it into Positron. And what I want you to do is ask Posit Assistant to write that missing function in helpers.r. The documentation in helpers.r is good enough to tell it, what that function should do. The only thing we really have to make sure to do is give it the right name. Since we're already using it in code somewhere else, it does need to be named this one particular thing. But between this and that, Posit Assistant will be able to write the function. All you have to do is paste that in down here, click the go button. It will have a bit of a back and forth with you. I'm not going to spill the beans. Do it and see if you can intuitively work your way towards an answer. Don't worry about granting it permission for anything. This is Posit server, and if you make it fall over, we'll fix it. So go ahead and do that, and I'll give us a timer. And while people are working on this, I will try to answer some of the questions in the chat. Jonathan Burns, you asked a very interesting question. Any idea when Positron Assistant will be out of beta and into GA? It's interesting because there's several things going on there. Posit Assistant, what we're using today, doesn't have the Tron on it. It's just called Posit Assistant. I believe that will go into GA in July. There is something separate called Positron Assistant. I know the naming is really confusing. That is the first generation of Posit Assistant. It was never released into GA. It's always been experimental, and it never will go into GA because we're standardizing on Posit Assistant, which is the second version of Positron Assistant. So as of July, when you install a new version of Positron, it will not have Positron Assistant. It'll just have Posit Assistant. But if that's just an innocent mistake and you don't know what Positron Assistant is, don't worry about it. It's just a previous version that's going away. Is it possible to set settings what Posit can see in Positron? I know there's a lot of settings. Sarah, do you have a definitive answer to that one? Because I know I can't say definitively, but.
Yeah, so you can, there are certain ways to control what it can see, but generally we don't recommend like working in an environment where you only want it to see code but not data. It's really easy for models to get around that kind of constraint. And so if you have data and are working with a model provider that like absolutely can't see that data, that's probably not a like you probably don't want to be using that LLM in that environment. So instead, we generally recommend like if you have sensitive data, your organization needs to have a agreement with the model provider where like it's okay for them for you to provide them with your data. Like they're not going to store it, all these things. That being said, you can there is I don't know if it's worth. I can add some details in the chat, but that's the general answer.
Thanks, Sarah. I think we briefly thought about like how we could securely let your model work with data, but I think it became pretty obvious that you can't keep data away from model and you got to trust the model itself. Which model providers are happy to give you some sort of arrangement where you can trust their models because they know companies can't use their models otherwise. All right, so let's go back here. I didn't actually run this. I will run it in a second, but there was just a quick question in the chat about how I got that Python session. So I just wanted to show you that. This is my console window. When you first open Positron, it's going to make a guess based on the files in your directory, what you want, Python, R. I think it just opened this because I left Positron and came back. But if you want to open any session, this plus button, here's the way to do it. If you click plus, it's just going to duplicate your current console, which probably isn't what you're after. The drop-down menu has the start another, which allows you to then pick whatever's available. So that's the answer. In the console, the drop-down menu next to plus to start another console. All right, now let's take a look at what happened when you click Posit Assistant. I gave it this prompt. It's now sending it off to Amazon Bedrock, who's using a Claude model to answer it. It's getting a little extra context, like it's getting this file, so it could read that documentation, use that. Although it hasn't got that yet. Actually, it's stopping to ask me, can I read this file and use it? And it's asking me permission to do that. And I could click allow, or I could click decline. It probably won't be able to do my task if I click decline. But in addition to allowing it to do it once, with this drop-down menu, I could say, I'm fine with you doing this the whole time we're here. For this project, you have read permission. I'm going to do that just so I don't have to click all the time. So now it's reading that file. And it's telling me what it's doing as it goes about its job. So it's looking at the Georgia cases data set. So I did ask in the prompt to test it on the Georgia cases data set to make sure it works. So I guess it wanted to know how that data set worked. It didn't get the data. Instead, it wrote some code and gave it to my computer to run. You can see my computer ran it down here in the console. My computer has the data, it has R, so it can run code. And AI is really good at writing code, so it's a simple job for AI to write the code and give it to my computer. That's what happened. My computer gave it back the results of that code so it could see it and use that to make decisions. All right, so now it says, okay, I'm going to write that function. I know what I need to do to write it. In fact, this is what the function is going to look like. This is a bit like a GitHub diff. If you use GitHub, the green lines are new lines that the AI wants to write. And the pink lines are old lines that it wants to delete. And once again, it's asking me for permission. Can it edit my file in this way? And once again, I can allow, decline, or give it a more blanket permission to do so. And I'm going to allow it to edit files in this project. So I click that, and now it edits the file, and I see I have this function here. And since I asked it in the prompt to try out that function, make sure it works, it's going to try it out. By the way, I do recommend asking the AI to try out functions so you know whether or not it hallucinated. If it did hallucinate, it would fix it since I asked it to make sure it works. But if I didn't ask it to do that, and I just accepted the code and then I ran it and found that it hallucinated, well, this is just a text file. I could hit Command Z and undo the last bit of typing and go back to where I was. All right, so it makes a plot. It looks like this. To be honest, in my mind, I pictured the bars going the other way. It doesn't matter. I could keep this, or I could just keep the conversation going. I could say, change the function so that the var variable, because I named it var over here, appears on the x-axis. And then it should be able to handle this no problem too. So one good thing for us in this new world of AI is that one of the tasks that AI is best at is writing code. And that's generally what we'll be asking it to do. And so we're going to deal with hallucinations a lot less than other folks would if we were just asking for like facts or something. And two, if you hallucinate while you write code, the code just doesn't work. So we could fail really fast and figure that out and then just fix it before it causes too much trouble. Okay, so now I have the bars the way I want. This is great. And if I go back to miss, save that file, I'll make sure to resource that file so I get the function that's in it. And now if I run this line of code, it should make something for me. And indeed it does. It makes the same plot that it did when it tried it out because I asked it to try it out with the same variable. All right. Now here's where I'm going to lay it on thick. What you see in this miss file is all of the R code you need to develop for this workshop. After this, we're just going to repackage that small amount of code in very increasingly useful ways. And this is what I mean by a small investment in writing code or encapsulating your work in code sets you up to then leverage that work in some fascinating and opportunity providing ways. All right. Let's see. It's been an hour and 5 minutes. Before we use this code, I propose let's take a 5-minute break. We'll start at 11 past the hour. I see it's 6 past the hour. And I won't get going again until that time. I will stay here for this break. So if anyone wants to chat with me or ask questions while people are taking a break, do it. But I'll see everyone else at 11 past the hour.
Garrett, sorry I missed this. I was trying to answer questions, but what provider did you use with Posit Assistant?
It's Amazon Bedrock right now.
Okay, so and that should work for everyone.
Everybody.
Okay.
Yeah, it's pre-configured.
Great.
Let me look into, are people having trouble?
No, there were just some questions about using Posit AI with Posit Assistant and Positron, but I forgot that in Workbench in Positron, you can't currently use Posit AI. So that's why you're not, for the questions about that, that's why you can't currently see that as an option. Oh, my name is updated now.
Yeah, I just like, I wonder if this rename function works. It does. Uh, So, Nathan, you're asking why we're using Bedrock over Anthropic. I mean, the very practical answer is because Posit at the moment has a contract with Amazon Bedrock that's, favorable to us. But Amazon Bedrock is reselling the Anthropic models. So we're using the Anthropic models through Bedrock. And from what I've seen, this is pretty common, and Bedrock's providing value by basically providing a layer of security here. So um, I believe Amazon Bedrock provides these models in such a way where you don't have to worry about Anthropic getting your results or something like that. Yeah, and your follow-up comment about pricing, like normally these things either come down to pricing or security, you know, trust, you might say. Or you use a suite and it's associated with that suite of technology, or you have to validate the technology you use and the work's been done for one thing but not for another thing, and you don't want to validate a second thing. What I've noticed amongst the places I go teach at, there's just a lot of path dependency that determines it at the end of the day, a lot of bureaucracy. How did I create the different versions of the instant rate charts? John Rosenfelder. Actually I have Zoom over that panel, so let me just. This is the history of the charts that I've created so far. So earlier here, when I asked Posit Assistant to make this chart, I asked it to try it out to ensure that works. And even though the chart's appearing over here in the chat window, everything that involves code that the assistant's doing, it's doing by sending the code here. And so it made that chart by running the code here, which means it also appeared over here. And that's why I have this chart in there. This was the very first chart that I demoed to you guys. The plots pane is keeping a history of the charts that I've made, so I could just go through them. And if you make more than one chart, you'll start to see that history too. So there's no magic there. Pablo, I see your question up above. Can the chat work in Spanish? I would love to say yes, but I actually don't know. Did you try it out? Did it work?
It should work. I mean, there's no like specific affordances for other languages other than English, but I just looked at the language use data for Posit Assistant, and there's actually like quite a few people who are chatting to it in a language other than English. So it should work. Can't promise that it is good. But if you try it and have a bad experience or something, like let us know.
I would suspect that the performance would rely quite heavily on the underlying model. Like since this is sending it to Claude Sonnet, it probably does depend on how good Claude Sonnet is at Spanish, but I assume they're all actually quite good at other languages. Yeah, so I'm gonna wait till the minute ends and it's 12:12, and then we'll get started just to not catch anyone off guard. Okay, so it is 12:12. So welcome back, everybody. We're in the second third of this workshop, and we've just learned how to use AI inside of Positron, and we used it to create a function. And now we have a complete set of functions that make all the elements for our target Shiny app. So we're going to, from this point on, sort of march up a progression of reporting modes that will finish with an AI-powered Shiny app deployed on Posit Connect. But we're going to start modest. We're going to start with a Quarto report. Quarto reports are how I recommend writing our code. There's definitely a place for scripts, but if you're doing data analysis, I think the Quarto medium is a really interesting choice because it has some benefits to it. So let me introduce that with a slide. This is what I mean by Quarto. if you've ever used R Markdown before, or knitr or SWeave, it's the latest incarnation of that chain of development. In fact, UAZ, the guy who made R Markdown and knitr, helped build Quarto. The difference between Quarto and R Markdown is, whereas R Markdown is a file format specifically for R files, Quarto is language agnostic. So you can use it with Python, you can use it with Julia, you could use it with SQL probably. And it's very, very well documented and contributed to. So what am I talking about? Well, first of all, if you're new to Quarto, this website, quarto.org, is definitely the place to be. It will tell you how to do anything that you want to do here. But to give you a sense of what you might want to do, I have a Quarto file in the file browser, and so do you. So if you click the files icon up here, you'll see that there's a file at the bottom. It's called report.qmd. QMD stands for a Quarto Markdown document. And if we open it, it's an unfinished file. But what you see inside of a Quarto report is, like I said, similar to R Markdown, but also somewhat similar to Jupyter Notebooks, if that's your prior exposure. We have places where we could write text. And if we write it in the Markdown format, then we can do things like headers and bold and stuff like that. But in between those text sections, we have code cells where we could write code here and run it. And my code cells in this document are empty. That's on purpose. I do have some text in there. But let me just add that histogram code here just to show like how you'd run code. If you write code in a Quarto document, you could put your cursor there and hit Command Return to run it one line at a time, and it's go run it down at the console. Or above each code cell, there's a Run Cell button, and if you click that, it'll run all the code in the cell, no matter how many lines that is. And in each case, it just runs the code and does it. If you wanted to add a new piece of text, you could just type text. And if you wanted to add a new code cell, there's a button. The first icon up here will just add a new code cell for you. That's the easiest way to do it. You can also type all this out yourself if you want. At the end of the day, Quarto documents are just plain text files. But this is what I think the real magic of Quarto is. They're set up with the assumption that you're trying to create some sort of report. And there's a little section at the top of an optional section at the top of a Quarto document that explains how you want that report to be configured. In this case, we're going to make an HTML report of the contents of this file. And I also have some things set up here so it won't repeat back the code or any warning messages the code in the file generates. But the idea behind Quarto is once you've done your work, you could click preview and it will create this type of file. So when I click preview, this is going to create an HTML file, but R is going to go through every code chunk and it's going to run the code there and it's going to paste the output of that code into the HTML file. There's not much code in this file yet, but we can get a sense of what's happening here. Here's all the text that was in my Quarto document. And there was one code cell that's not empty. That code cell makes a histogram. So that histogram got inserted in place of that code cell in my final report. And then the rest of the text is down below. Now you can imagine making a report maybe with Microsoft Word and you put your plots in it, you generate them somewhere and you give them to your boss and the boss says, oh, that's great. Please change this plot. Well, you have the Word file, but that doesn't help you change the plot. You have to go find the old code and how it was working in the environment and recreate it and make your changes and then copy and paste it back into your document. It could get to be a problem. But when you have a Quarto file, your code is always right there in the place it needs to be. And to regenerate this report, all you have to do is re-preview the file. So maybe this was only supposed to be 50 random values. Let's just make it 10 so it's really obvious. I just change my code and I re-preview and it's going to update my report in place. And then this HTML file now exists right next to the original Quarto report. It's true HTML, so I could put it on a blog, I could put it on Posit Connect, put it anywhere I could host HTML, and I could share my findings. All right, so that's what we're working with. What I would like you to do is undo anything that you might have done following along with me. But then open that Quarto file, go through it, and just copy and paste over all the lines in miscellaneous.r into the different sections of that file. You'll want to read the file and the cell labels to get a sense of where to put the different things, but I think it should be pretty obvious. I'll get us started. So for example, actually, let me tell you a tip that'll help you with this. If you click on a file here, it'll open up in your viewer. And if you click on a different file, it'll open up, but the first file will go away. So I always just have one file open. That's useful in some situations. But if you want a file to stick around, like you're going to be copying and pasting on misplaced R, double click it, it'll stop being italicized. And now when you click another file, the first file will stay. If you want the second file to stick around, double click on that one too. So that's how that works. All right. This first chunk is called setup. This is the code that sets up what comes below. So I'm going to copy and paste it from here into that setup chunk. It's a mistake to have this line comment out, so I'm going to make sure I don't do that. And then there's other chunks that require other bits of code. So go through there and paste your code over and then hit preview and see what sort of report you get. Michael, that timed out error, did that come from R or from Workbench? Like if you take a screenshot of it, I could try to interpret it. Michael, where does it say error timed out? I'm having trouble finding it in your screenshot. Well, if it's working now, you're probably in good shape. Okay, cool. You should be able to do this without making Posit Assistant do it. But that is a good use of AI, which will be an important skill. All right. I better get started catching up to y'all. So I did do this first section. If you read through this, you get the sense it's reporting on the incidence of cancer in Georgia. And it tells you like, here's a map. And since we've run these functions, we know the first one creates a map. So let's give it a map where it's asking for it. Next one asks for a chart that shows incident rates by race or ethnicity group. That sounds like what the last function did. So put that one in that code cell. And then the final one says, here's a table of the data. And so I'll paste the data table line in there. All right. Now, one thing that's important is like, we really do need to make sure that this document is going to run these library commands, because when we preview it, it's going to run in a fresh session. So it's going to need to load up all the libraries it plans to use over in that fresh session. So it needs to have the code that does that. It also needs to read in the data set, and everything it depends on, it has to do for itself. So now I'm going to hit preview. It's rebuilding my report. And some of the elements will probably take longer than others to come out of here. So it shows me over here on the side, if this is too small of a window to look at, we can drag the bars here. And also you could pop it out. Like there's a little obvious pop out button, and that will open it in its own web page. So if you prefer to look at it that way. And again, this map's doing quite a bit of work for us. But this is an HTML map, and since we chose an HTML format, it has this cool hover over features. The whole world is here if we want to scroll around to see it. And we can zoom in and out. This is made with a package called Leaflet, and it's just using by default maps from the OpenStreetMaps project to help us plot our data. So that's actually a really cool way to explore visual data. All right, getting back over here, we have that report. That looks pretty nice. This is how you can create a narrative report to share with folks. But there's so much more to Quarto. It's designed to help you create so many, many different types of reports. And in fact, if I go back to the Quarto webpage, it has a gallery of the different types of things that you can make with it. So we got reports, presentations, which means slideshows you can make straight from your work, dashboards. I made that one right there. websites, books, I don't know what else on the web page, but you can make many, many different things with the same Quarto format. In fact, you can make multiple outputs from the same stream of work using Quarto. So it's really useful. What I'd like us to do now is push a step further. Let's make a dashboard. These are all dashboards made with Quarto, and I'm going to teach you how to do that. It's hopefully simpler than you imagine, and then you'll be able to make dashboards pretty quickly. All right, so I'm going to close that, do a little tab management, come back here. I'm just going to hit this X to close this, just so I have more space here. We're going to work in our same Quarto QMD file, but we're going to transform it from HTML to a dashboard. And that's going to begin with this line here where we tell Quarto what format we want it to create with our work. So let's learn a little about that. But Quarto itself, text and code, you click run cell to run the code, you could preview what you're doing, is totally great for developing your code as you go. Like that's where I do my coding. And then at the end, like just as a great side effect, you could produce a report from it. So it's not like you have to start with the report in mind and then retrofit all the code in. It's a medium for working. You could preview what's happening as you're developing and make all the changes you want, and you could export what you have into many different formats. So we're going to try making dashboards with Quarto. It's a little genius, I think, how it does this. So the way it works is if we change the format up top to dashboard instead of HTML, first, we'll probably want to just get rid of all the text in our document. Text isn't really something that you like to see in dashboards. Dashboards are more just like the data. So we'll erase all the text. But every code cell in a document that goes format dashboard, by default, will become a card in the dashboard. And they'll just start getting lined up next to each other. So let's go lay it out in this dashboard format. But we want control over the layout, so we could take that control. Every cell becomes a card, but if you put a 2-level header before the card, that will start a new row. So if I want to organize those 4 cards into 2 rows with 1 card in the first row and 3 cards in the following row, I'll put a 2nd-level header for the first card to start that first row. And when I get to the end of that card, I'll put another 2nd-level header to jump down to the 2nd row. And then I'll let all those other cards be in there. And they'll fill up the row. So that's pretty straightforward. We're using the headers, which in Markdown, you make a header by putting a certain number of hashtags before some text to make our rows. I'm calling these rows group 1 and group 2, but those names aren't actually going to show up in the dashboard, so you could call them whatever you like. But you might want a little more control over than just like breaking things up in the rows. You might want to break up in the columns too. And if you could do both those things, you can make pretty intricate fractal dashboard designs. You can make columns with a 3rd-level header. So that's a header with 3 hashtags in front of it. So it becomes a bit sophisticated to think about, but the rules are simple. Every time the Quarto document hits a 2nd-level header with 2 hashtags, it will start a new row. Every time it hits a 3rd-level header with 3 hashtags, it will start a new column within that row. And then every code cell will be grouped in its own card. Now, something to think about. You could make multiple plots from the same code cells, but they'll all be grouped in the same card, right? So it's the code cell itself that becomes the card. Now, this will let you do, I would say, about half of the layouts that you have in mind for a dashboard. The other half are layouts that begin by splitting by columns first. This default format always splits by rows first. So it's called row-wise format. If you want to split by columns first, up here in the format option, you have to write a little more. Instead of just saying format dashboard, we'll put dashboard on a new line. We'll indent it 2 spaces. The syntax is called YAML, by the way. And then inside of dashboard, we'll set this option. And this option will be called orientation. And we're going to set to columns. And this is how you tell Quarto that when it makes a dashboard, start with columns first instead of starting with rows first. And then it just sort of flips everything. Cards still become their own cells, but now they're arranged downwards in a single column. If you want to start a 2nd column, you do that with your 2nd-level headers. So if you set orientation to columns, every time it hits a 2nd-level header, it starts a new column. And then, as you might predict, when it hits a 3rd-level header, it's going to break that column into rows. And between the first option where you just divide by rows first and the second option where you divide by columns first, you can sort everything into the grid that you imagine in your head. None of your code is changing. Most of that core report staying the same. We're all going to delete a bunch of text to do this. We're just manipulating the format line and where we place our headers to get a dashboard. In February, I showed some people this and they realized that they could make a dashboard for free that they had already invested 100 grand in making and putting on the internet to share with the world. So I think it's underrated. Let's make a dashboard. Maybe it'll be high value to you and your consumers. Oh, one last thing. Quarto is going to just split everything equally if you're just using your headers. Sometimes you want to say, well, actually, this row doesn't need to be as big as the rest. I want to shrink it compared to the rest. The syntax for doing that is in the header that makes that row or column. Use this CSS syntax. Use either height or width. You're going to be talking about do you want the height to shrink or you want the width to shrink? And it's pretty touchy. You definitely need to use braces after the column name. Within those braces, do not use quotes. And do not use spaces. If you use spaces or quotes, it'll just ignore it. And what we'll be setting it to is percentages. So if I set this, the header that starts this row here to height 25%, it will make that row 25% of the column it lives in. And the remaining rows will expand accordingly to fill up that space. All right. That's a lot, but let's try it out. Let's see. I think it's actually pretty simple once you work with it a bit. So let's try to take the elements of our Quarto report and refashion them into a dashboard that looks like this. Notice it's 2 columns. So we're splitting by columns first. The second column has 2 rows. One of those rows is a lot shorter than the other. You could go 25%, 30%, whatever you like. And there's no text in between the stuff. All right. So see if you could do it. Towards the end, I'll come over and start doing it with you, but give it a try. Try to do it manually first. We'll come back to it and we'll do it with AI in a second. But I think even though we live in a world where AI can do everything for us, at least understanding the concepts and being able to work with them will help us use that AI better. So try that manually and then we'll take a look at it. And you're just going to go right into your Quarto document and just start making changes and clicking preview and seeing what happens. John Rosenfelder, were you able to get unstuck? If not, I can help. Okay, so we're in the final 30 seconds. If you're stuck or it's not working out, let's do it together. Because I need to catch up with you. So the first thing I'm going to do is I'm going to change this format to dashboard. This would make a dashboard that starts by organizing things as rows. But in this case, I want 2 main columns and then the second column organized rows. So I want to split by columns first. So I'm going to add that option we covered, dashboard, orientation, columns. Right. Now, I might just start there and preview this and see what happens. I'm sure it's going to look zany and wacky because I haven't given any thought down below. But let's see what it is. Okay, so it doesn't look very different from anything. A lot of text in here, report. But I know in my final dashboard, I don't want text. So I'm just going to start erasing the text. In fact, I'm going to erase everything, even the headers. That'll make it easy for me to come back in and build the dashboard I want. So I just want the code cells. Those will be the cards of my dashboard. And everything else is gone. So now if I preview that, it takes a while to preview this table and map. So maybe I won't preview it every step of the way. But what I should see is a dashboard that organizes all those cards into a single column because I chose orientation columns. Well, that doesn't look like a single column. That looks like a single row. So let me pop this out just to see how it would appear over here. Okay, either everything's its own column or I messed up the slides. But let's go back to here. I just want to check and see if I didn't add this, would I get a different effect? I'll preview that. I mean, I do have a nice dashboard of 3 things in a row, but I want more control over my layout. So let's see how this goes. Where's my bar? Okay. Okay, maybe. Oh, I made the slide wrong. Okay, so everything is its own row, and the other one is everything is its own column. Okay. I'm going to go back to where I was. Make it like this. I'm going to use some headers. So I want the map in its own column. So I'm going to make this, I'll call it column 1. And I want everything else, or the last 2 things, in a second column. I'll call that column 2. I'm using the second level header because this is like my first division. You can use a first level header. It'll just put things on a new tab. I don't want to get into tabs. So I'm going to do this. Let's start that previewing. Close this because I'm not using it anymore. And then within the second column, I'm going to want these to be on different rows. So let's see what happens here. All right, so that's looking pretty good. So now I do have 2 columns and the plot is on top of the map. The only thing I might change is I don't know, I like to see more of the data. So I'm going to try to shrink that plot. And to do that, I'm going to need to formally make those 2 rows. So I'll call this row A. It doesn't matter what I put here. And I'll call this row B. But the reason I'm doing that is so I can then specifically use the syntax to make the height of row A with no quotation marks, no spaces. I think it said 30%, so I'm going to make that 30%. And now we'll preview that. And hopefully we'll get something that looks like what we're anticipating. But this is how you make a dashboard. I mean, this is a dashboard. We're just tweaking the layout. Right. While it's running, that's definitely not what I want. I think I got this all backwards, maybe. What this would do. Okay, while that's running, I want to point out this dashboard is an HTML file. So dashboards are HTML files. It's also going to be called report.html, but that means you can host your dashboard on your website, on Posit Connect, anywhere that can host HTML files, which is many, many places. All right, this isn't working. So I'm not getting anywhere, but I was planning to show you something that you could avail yourself to. I'm going to avail myself to it as well. As we work through these exercises, if you fall behind or something's not working, you just can't figure it out and you don't have time to figure it out, maybe because you're giving a live presentation in front of 100 plus people, there is a folder called solutions in our directory. And inside that folder are sort of all the milestones that we're going to hit today. And these are places where you can check in. So if you didn't get that function written for helpers, you could just copy and paste what's in 00 helpers into your helpers file, and you'll be good to go. If you didn't make it to the report phase that we got to, you could copy 01 report. And I wouldn't use it here. I would copy it out into report because we're going to keep using these documents. But then you'd be up to date with the rest of us. And if you didn't get this dashboard exercise like me, which I might just set up wrong because I swear this is going to be the same thing. Seems like it. You could go into the file, hit Command A to copy all of it, and then go to report and hit Command A, Command V to paste over all of it, and then preview what you have. And that will get you caught up. And you can see we're going to do other things too today, and you'll be able to use the solutions there as well. All right. The one danger of the solutions file is all these files are meant to work at the top level. Like they include file paths that only work at the top level, but they're hidden in the solutions folder, which is 1 level down. So if you run them where they are, they're not going to work. They're not going to find Georgia cases and helpers. They're just there to copy and paste out of. Okay. All right, so something I wrote was not right. I'm not going to be able to take the time to debug it, but now I do have a dashboard over here, and it's set up the way I want, and it has the columns. And if you copy and paste, or if you just got there naturally, you'll have this dashboard too. All right, let's try one other thing. Let's do this as a group. I have another prompt in here, and that is we could have asked AI to do this, and some of you may have asked AI to do this. You could do that in any way you like. I have this prompt, but let's, as an exercise, go over to report.qmd. Maybe you don't want to do this. Maybe you just want to follow along with me. I'm going to find my report. I'm going to use the undo button quite a bit to get back to, oh, there's a better way to do this, but get back to how it looked when it was a report. And now I'm going to ask Positron Assistant to do this work for me. So I'm pasting in my prompt. I'll find the chat so you have the prompt too if you want to use it. I gotta make sure I'm in a meeting. All right. And then I don't know if this is even fun to look at. AI should be able to do this for us, and I anticipate that it's going to do it for us. All right, can it read that file? Yes. So previously I gave it permission to read .r files. Now I gave it permission to read .qmd files. It reads the file. Let's go turn into a dashboard. We'll see if I describe the dashboard well enough in this prompt for it to get where I had in mind, but it is limited by my descriptive abilities. Okay, what we're seeing now is interesting. So it's saying, can it use read? And what read here is, well, I mean, it can use read, that's fine. Can it read the skills file? The skills file is an example of one of the lessons that we're providing to the model as we bring it into Positron. And this lesson is about how to lay out Quarto files. So that's not something Claude Code might know very well on its own. But since we're using it through Posit Assistant, it knows it has access to the skill. It's decided it's time to use that skill. So it's asking me, hey, can I go brush up on laying out Quarto documents before I do this task? I'm going to say certainly yes. And it reads that skill. It's like the Matrix where like Neo learned Kung Fu. It now knows how to lay out Quarto documents. And now it's going to write that document. And now it's asking if I can write this core document. So I'm going to say, yes, you can write in QMD files. And this is how it made the Quarto document. Let's put to test and see what it came up with. There we go. So it did lay it out. It didn't catch the plot thing, but I might on the first match. But actually, I didn't mention that in the description. So I guess we can't fault AI for not reducing the size there. But of course, like AI is going to be able to do all the stuff we're doing today. And in your work, you could ask it to do that. I'm going to just copy and paste back in that solution because I like the fact that that plot's a little smaller. And now we're going to build a Shiny app that looks a lot like this dashboard. And in the Shiny app, I want the plot to be a little smaller too. So if I open up dashboard.qmd, copy all, open up report, copy all, paste, there. That will set me up for what comes next. All right, what does come next? Well, you've learned how to make Quarto dashboards. It's the Quarto format, the format you might be writing your code in and doing your work in to begin with. You don't have to worry about writing intelligibly anymore because we took out all the text. It was just code, and then we're using the headers to move the code cells around as cards within a dashboard. And now we have this dashboard layout to share with the world. But the dashboard just shows what's there. The user, they can't really interact with it. I mean, we do have an interactive plot and a table, but what we want to build now is something that's truly interactive. I'm getting ahead of myself. Command Z, if you have AI features that You test it out, but you didn't like them. That just undo them like you undo your own typing, right? Actually, let's pause before we get to Shiny and publish our dashboards to Connect. It's a good place to do it. We're a little past halfway through the workshop. Connect is a place to share the things that you make with Quarto or with Shiny or with QueryChat or with Python or with Streamlit. It's a place for hosting data science artifacts. And the idea behind Connect is it puts the data scientist in charge of publishing their own work and updating their own work and maintaining their own work and seeing who's using their own work without having to rely on an IT team to get around to updating your app or running it with the new data or whatnot. You get to be in charge. And right now we're going to use Connect, the professional version that's on this server, but there's also a free version in the cloud that anyone could use. It's called Connect Cloud. They're both made by Posit. Let's get it this way. Connect is this other thing I said earlier that we would use. It works with Workbench. Workbench is where you write your code. Connect is where you publish the results so people without coding experience can go use them. And then package manager is just the third thing that supplies the validated and secure packages that you want to make sure all your code's using within your organization to both of those. How do you get to Posit Connect? Well, from inside Positron, it's fairly easy. You got two options. One, at the top of your file that you publish, there will be a round icon. It looks like an arrow going into it. That has push button publishing to Posit Connect. And that's what we'll use. But there's also, there's also a place to push your code to Git. It could be GitHub, GitLab, any Git repository that you use if you use version control. And you can ask Posit Connect to publish from a version control repository. And once it's published from there, it will monitor that repository. Anytime you push code to it, it will then re-update and rebuild whatever you have on Posit Connect. So let's look at that over here in Positron. I'm going to show you the GitHub thing. We're not going to use it. We're definitely not going to push back into this repo. That'd be a little inconvenient for me. But it's this icon here. It looks like a fork, is keeping track of all the changes we've made so far. We've made 60 changes since we pulled from Git. And we could use this to stage some of these changes into commits and then push them back up to Git. There's all sorts of ways to interact with Git. We could see the commit history for this repository. We could see what branch we're on. We could change it if we wanted to. All of this comes straight from VS Code. Positron's a fork of VS Code, which means all this was made by Microsoft, who happens to own GitHub.com, the largest collection of Git repositories in the world. So we're fairly confident that this is a great Git client, and that's been our experience with it, and I recommend it to you if you are a Git user to explore. But we won't go any further down this path today. In fact, I'm going to unstage this and go back to my files. Instead, we'll use push button deployment, and you'll see at the top of your dashboard file, you could do this in whatever state your dashboard's in, as long as it does make a file, non-error. There is a circle with an arrow in it. It says deploy to Posit Publisher if you hover over it for long enough. Let's click that and we'll deploy this dashboard to Connect. We'll click it and it's going to lead me through a dialog. And if you do this at the same time as me, we'll go through the dialog together. We'll see how it works out. So first it's saying, do you just want to publish that HTML file you made, or do you want to publish this document with our code in it that builds the HTML file? I always publish the source code. There'll be real advantages to that we'll see over on the Connect side. So select publish document with source code. It's going to ask what we should name it. Since our document has a title, it just assumed we want to name it that. And I'm going to hit enter because that sounds good to me. And now it asks, do you want to publish to Posit Connect Cloud or Posit Connect? Let's publish to Connect, the second choice, because on the server we're using today, we do have an instance of Connect that we could publish to. So I'm going to publish to Connect. It looks on the server, it finds the URL of the Connect instance and says, did you mean this one? Yes, I did. So just hit enter there. And it says, okay, this is your first time publishing to this instance of Connect. I don't know if you're allowed to do that. You got to prove you have permission to publish there before it will accept what you're sending. And it's really easy to prove that we have permission. Just click the first option, token authentication. We can all do this. It's going to say, okay, I'm going to take you to Connect where you're going to log in and show that you have an account there. Fine, open it. And now we're going to have to log in. So we're going to see what happens here. So think back to the account you used to log in to Connect. If you can't remember it, you can make a guess, or you could just watch and follow along. It's really not that big a deal. So I used, my account name was Garrett36. And that shows a very clever password. So hopefully it'll recognize me when I click sign in. Cross your fingers. It did. I signed right into Connect using the account that I made earlier. And now it's saying, okay, hey, Garrett, I'm glad you're here because someone says he's you and he's trying to publish. Does that person have permission to publish? And I'm going to click Connect to grant that person permission. Succeeded. Now I could go back to Positron. It knows I succeeded. It says, okay, we're good to go. We could connect here. Let's get busy. So I'll hit enter. But before I do, let me just check. We were interacting with the server again there. Did anyone run into any server issues again? So hopefully if you wanted it to work for you, it did work for you. All right, great. So we haven't published yet, but we are connected to this instance of Connect so we can publish to it. And to do that, I'm going to just hit enter. And now it's going to take me over to the sidebar. This is where I finished the job in the sidebar. I have the chance to select which files I want to publish alongside this report.qmd file. If you look at report.qmd, it reads in the Georgia cases RDS, and it also reads in helpers.r. So if I don't send those along with it, it will not run on Connect. It will hit an error. So I'm going to click helpers.r and Georgia cases.rds. And now they'll be included in what gets sent to Connect. Some other things are already clicked that are necessary for the process, so don't unclick them. And then report.qmd is already clicked. Once you have helpers and cases clicked, click deploy project. And now what's going to happen is Positron is sending those files over to Connect, along with some information that's collected about the environment we've been running our code in, what packages we're using, that sort of thing. Connect is now building a container that has that version of R and those packages so it can run the code too. Then it will run our code to rebuild this dashboard, and it will make it available at a URL that we can then share with folks and they can visit over their web browser. The whole process should not take that long. I don't know how many people are doing this at the same time, but I don't think it'll get tripped up. So if we wait a few minutes, we should see it happen. And one of two things will happen anytime you do this. One, either it will succeed and it'll give you the option to look at your content, or two, it will fail, probably for some, it hit some bug or something. It'll give you the option to look at the logs and read them and see what error message you got. So this succeeded for me. It says, do I want to view the content? Also over here, this turned into a view content bar. And if I click either of those, it'll take me to Connect where I could see this dashboard. Let's see, there it is. So there's my dashboard. I have my hover over effects, which came from the leaflet package and the DT package. It's just what these things do. But the cool thing about putting this on Connect is I can now share this URL with other folks and they could visit it. But I could go into the settings here and make the process even sweeter. If I go to general, I could read a little bit about my app and I could delete it and stuff if I want to. I could write a description for it. I could give a little picture that shows up as, for Connect users when they see it in their menu. But if I go to access, I could change this URL. Maybe I'll make it Georgia dashboard or something. I'll spell it correctly. No, I won't spell it correctly. All right. And I'll get zoom out of the way. No, I'll put zoom back in the way. I'm sorry, this is a little laughable. I'm just trying to get to the save button. Once you click save, the URL changes something a little nicer to share. Totally optional. But I can also decide who gets access to this app. I can make it available to the world by clicking anyone, no login required. I could, I don't know why everything just went away there. I could decide only users on my Connect instance. So if your company runs Connect and you just want to keep it in-house, only they could see it, I could click that. Or I can make it even more specific. Only specific people in my company on Connect can see this, and then I could start writing their names and searching for them here to add them. All right. And then one other thing to show you about Connect while we're here with this is, since we published the R code that builds this dashboard, and Connect can run R code and Python code and other types of code, I could go to the Schedule tab and I could say, you have the source code for this. So rerun that source code every day or every 2 days or, every week. I can set up some sort of schedule here. And if that source code is pulling in data, reading in data, then every time it reruns, it's going to read in the freshest version of that data. It could be connecting to a database, Snowflake, Databricks, a CSV file that just gets added to every week. But if I schedule this to rerun every week, then I can be confident that every Monday before people come into work, it's going to rerun, and then it will be up to date with the latest data going forwards. And I don't have to manage that process, and Connect's going to do it automatically for me. And then if I want to make my own change to this sort of thing, to this document, discard, I don't want that to rerun. Going back over here to Positron, I can make any changes I want to my file and then just redeploy it and it'll get pushed up to Connect. And so this is where I don't have to interact with the IT team. As long as IT installed Connect for my company or my university or whatever, I'm free to use it as I like. And it will be within my skill set because it's designed for data scientists. Okay, so what if you don't have Connect? I'm showing you a bunch of stuff that's just a sales pitch? Well, yes, but also no. The free version of Connect is something that's run by Posit on the cloud, and it's a premium model. So there's free tiers, and then there's also, you could pay us for larger tiers depending on how much compute you're consuming. But it's at connect.posit.cloud, and you can see I of course have my own account and I have lots of stuff on it. And this is the sort of thing you could do. You could put it here, and then this probably would take for a load. I'm sure I haven't loaded this a long time. But then you have a URL where you could start sharing things with people from without buying Connect. Okay, let's get back to the course. What we have right now is a published dashboard. It has some limited interactivity because we use an interactive plot in it, but I would like to give our users the chance to select specific types of cancer so they could find hotspots for I don't want to say it's cancer names I'm not very good at, but stomach cancer, I could say that one, or whatever. That sort of interactivity I can't provide through the out-of-the-box leaflet map or the out-of-the-box data table. I'm going to need to create an interactive app to do that. And I'm going to do that with Shiny, and it's going to be surprisingly easy because now we have AI on our side. But it's been the top of another hour, so let's take a 5-minute break before we do that, and we'll come back here at 5 past the hour. We'll build a Shiny app, and then we'll add AI components to make it a QueryChat app, and then we'll finish. This time I am going to take that break with you, so I'll just see you at 5 past the hour.
Yeah, I also have to go because it's 11. But so see you later.
Thank you, Sarah. We
enjoy the rest of the workshop, everyone. Bye.
Oh, yeah. Right, Yuan, I'm reading your message in the chat, and that scheduling feature doesn't work with Shiny apps for a specific reason. When you host a Shiny app on Connect and a user visits the app, Connect launches the app for the user, and that is basically like rebuilding your dashboard. So it will always be up to date in that sense. Whereas with a dashboard or a quarter report, you don't have to build it and launch it. This might make more sense as we go through Shiny apps. You just need to have that static file to give to the user, and we're scheduling it to update that static file. And then in between scheduled dates, it's just go be lazy and give that same static file to everybody. Emma, thanks for attending. The video should be on the Art of Medicine website in a couple of days. So do check back in and see how it ends. All right. And for everyone else, it's 6 past the hour, so let's get started again. Now, in the first hour, we reviewed R, we learned how to use AI and Positron, and we learned how to use Positron. In the second hour, we learned how to make Quarto reports and Quarto dashboards and publish things to Connect. And in this last hour, we're going to learn how to make Shiny apps and QueryChat apps and publish those to Connect. And if you don't know what a Shiny app is, it is an interactive web app built with R or Python. Shiny works in both languages. And if you want to learn anything about Shiny, this is the web page to do it, shiny.posit.co. It is a terrific website with 10 years of content, and you could teach yourself Shiny there if you want. But you don't have to do it alone because I'm going to help you learn about Shiny right now. Let me get back into presenter view. All right. The basic idea behind a Shiny app is it's a web page, and that web page has two different things in it. One set of things we'll call inputs. These are things that your user can manipulate, like a drop-down menu. That's what we'll focus on today. But it could be a slider, it could be a calendar, date picker, the sort of thing that you are used to interacting with on websites with your mouse. Those are inputs because they let the user input a value into the app. And then your app will also contain outputs. And outputs are just anything you could build with R or Python. And they're things that are probably built with the values the user provided to show them something. That's what lets the user drive the app and get interactivity and find what they're after. So we're going to mentally think about these things separately, how we build inputs and how we build outputs and how we put them together into a Shiny app to give to the world. In a Shiny app, once it's working, whenever the user changes an input value, any output that uses that value will automatically update to reflect the new value. So essentially, we're going to be building this map using R, but it's going to filter the data by a cancer type that the user supplies. And whenever they change that cancer type, the map will update to show the filtered data. It happens automatically and quickly, so the user feels like it's a really interactive, nimble experience. To build apps like this, I mean, at least 15 years ago when we started, that sounded like really complicated. But it's actually surprisingly simple. I think it's still surprisingly simple, although people probably have higher expectations now. Everything starts with the code you see on the screen here. I like to think of it as boilerplate code for making Shiny apps or a template. When you start an app, you'll use this code or something very close to it, and then you'll elaborate upon it. And I've put this code in a file in your directory called app.r. And what I'd like you to do is find app.r and open it and press the play button at the top of the file. It'll be where the preview button formerly was, but that will run your app. So spend a minute doing that. Look at the app. What you see might be perplexing, but probably will not be a reason to panic. All right, it's my turn to join you. I'm going to close some of this stuff here. Okay, so app.r looks like this. That's the code we had before. And if you run it, R is going to, well, Positron's going to start an R session to run it in. Let's go preview the app over here. When you have a Shiny app, there's always a computer behind the app, watching the app and powering the app. And we see this little red square here when you have a Shiny app running. That's telling us that part of our Positron process is watching this app, ready to respond to whatever changes the user makes in the app. And that's consuming cycles, and it might actually be preventing things from happening. So when we're done looking at this app, we're going to click that stop button to stop this process so we sort of get all our compute power back and we could keep working. Now, it's waiting for the user to do something to this app. The user's not going to do anything to this app. It's a completely white page. That's what you'd expect for a boilerplate Shiny app. This code makes a blank Shiny app, and it's up to us to add things to it. But what you did not see was an error message. If you did, let me know in the chat. This is a viable app, and it's a safe starting place. You'll notice that it has a sidebar. It's collapsible. It only appears once the app is wide enough. Sidebar will be down near the bottom, I think, until then, but there's nothing in this app. All right, we're going to build an app from here. So let's stop that. So click that red button, and you'll see it gray out and stop. And you'll notice that down in your console window, there's now an extra console called Shiny. It's just a second R session, and that was the session running that app. So our existing session was there too. Okay, we have a blank app. How do we fill it with things? Well, in the past, I'd spend half a day to a day teaching you, but this isn't the past. What I want you to understand is sort of the conceptual things that are going on in the background, how things in the Shiny app link up to each other, the different parts connect to each other, and then how to use AI to make the app. because with that toolkit, you will successfully be able to make Shiny apps. So here's the app template. And if we analyze it, we can see the two parts of the Shiny app that matter, the two places where we add things. And those places are these. Inside this UI function, so where it says page sidebar, is where we put things into the web page. Everything we put in here will show up on the web page. Anything we don't put in here will not show up on the web page. So this is truly where we build that UI. And it's also where we lay out the web page. So that will be where we put our inputs and our outputs because those show up on the web page. Inside the server function down here will be a set of recipes that we're going to give to the computer that monitors that Shiny app. That computer is normally a web server, so we call it the server function. And why does that web server need a set of recipes? Well, whenever the user changes an input value, that web server, that server, is going to rapidly run our recipes to rebuild the map and the table and the plot with the new input value. So we need to give it the code to run each time it needs to do that. And since we're not running that code, we're sort of like collecting it to give it to run later. It really is like a recipe we're giving it. In fact, I think recipes gives us a really useful analogy to think of Shiny apps. The web page is like a restaurant table with a menu on it. It's a place where we will be served and get what we want, and we could select from a list of options to get that. And then the server function over here is like the cookbook that we wrote to give to the chef and cook staff to provide those things that the user will be asking for. Okay, so that's the first big conceptual thing about Shiny apps. You have the outputs and inputs in the UI, and then you tell the server how to make one from the other in the server function. Now let's have AI make the app, and then we'll analyze what it made and see what a Shiny app looks like. So this prompt, I need to change that because I found out yesterday 6 minutes was way too long when AI is doing the work. This prompt I'm going to paste into the chat. Give that to Positron Assistant and work with Positron Assistant to get it to update your app.r file to be a complete Shiny app. Once it's in that app, press the play button and see if the app actually runs. I mean, hopefully it will, but if it doesn't, tell AI to get its act together and fix what went wrong. The clock's run down, so I'm going to do it too. So I want to find Positron Assistant. At some point, I could press this plus button to start a new chat, but since everything's building on itself, I'm okay using the same chat. And then also, if this is big enough, you might notice that there's a pie chart icon, I suppose, down here. Don't tell Hadley. If you click on that, it's going to show you how many tokens you've used in this session and what's using the tokens. And the fraction of the pie chart that's filled up is actually the fraction of your context window, I think, that you've consumed already. And we can see we have a ways to go. So we've like it's on 27 to 200 tokens before it would have to compact our conversation to keep going. So we're in a good place. I'll write this in here. See if it studies the contents of report.qmd. One reason I wrote it this way is if you have something specific in mind, I think Quarto dashboards are almost an easy enough way to sketch out an idea to give to AI to build your Shiny app. So this could be a format that works for you. To be honest, when I first made this exercise, I didn't trust AI to write this Shiny app from scratch. But nowadays I do. It got better. All right, so it's executing some code. It's reading app.r. This first one here, skills Shiny app bslib, that was it learning a new skill, how to make a Shiny app. So another one of those skills that we're giving the model. Now that's inside Posit Assistant. So it read the skill. It read the current app.r file. It's looking at the Georgia data set to figure out probably what the values of that dropdown should be. Now it has everything it needs. And it made this app. Okay, so this is another checkpoint in here. So if you, I guess I check, make sure. So yeah, this looks like much more than the template. It's an app. I'm going to press the play button here to preview that app. So it's going to start running it in this new session. I see that stop button there tells me this session's devoted to the Shiny app. I see this Shiny app. And if this Shiny app worked, then when I change this value here, everything in the app should respawn. So I'm going to change this to a different type of cancer. I see everything refreshing. And there, now I see the hotspots for brain cancer, but I see the chart and the data has also refreshed to show the original data set filtered down just to the rows where the site was brain and something nervous system. And then I should have every option here if I scroll through here, so I could get, to any type of cancer I want to explore. So that's a Shiny app, but we're going to spend some time looking at how it did that. Before we do that, I better stop this because I'm just telling you this because as a user, I'll make a Shiny app, I'll preview it, I'll ask AI to do something maybe, or I'll write some code and I'll hit run and nothing happens. And it takes me a long time to realize, oh, that's because my computer's busy with this Shiny app. And then when I hit stop, then I get my computer back. Workbench, which we're on, manages a lot of that for you, so you don't run into that. But we're not always going to be on Workbench. And it's a good habit to just stop the app after you look at what you need to see. Okay. The other thing I want to say before we go forward, if you've fallen behind, this is another milestone checkpoint. So you can go to solutions, open o3app.r, and copy all of that code and paste it in app.r, and you'll be right up with the rest of us. So you could do that to catch up. And AI did write this app, so you might notice some small differences between the code we look at and the code you have. Those differences apply to everyone, not just people copy and pasting this. But thematically, it should all be the same. And under the hood, it definitely all works the same way and obeys the same rules. That's what we're going to look at right now. What are the rules that govern a Shiny app? All right, made our app. That should be o3app.r. Apologize for that. But let's break it down into parts. How did it build the UI part, the restaurant that the user gets to come to and poke around in? Well, we're going to look for two things because we know two things are in the UI, inputs and outputs. And the way you add those to a Shiny app depends on whether you're talking about an input or an output. So here you can use your pen tool and just underline it if you could see it. In which line does it look like we provided a drop-down menu to the web page? And if you think you know, underline that line. Okay. So I see Darren, Roland. Didn't catch their name. Yeah. You all have spotted the right line. So we're inside the UI section. We added a title to our app. It appears at the top of the app. And then over here, we add select input. Select input is Shiny's name for a drop-down menu, but that is going to add the drop-down menu. One thing I want you to pay attention to on this slide is that select input appears inside the sidebar function. It's pretty simple, but this is how it works. If you put something inside that sidebar function in the template, it will be in the sidebar of your Shiny app. And if you put it outside that sidebar function, but still inside page sidebar, it will be in the main panel. So if you want it in the sidebar, put it in the sidebar function. If you don't want it in the sidebar, just put it after the sidebar function. The drop-down menu will be in the sidebar. And then just a second here. And then we're using a function called select input. That comes from the Shiny package. Shiny provides a set of functions that provide different types of inputs. Here's the basic ones and what they look like. Other R packages also provide inputs that you can use in a Shiny app, so you will find more types of input than just what comes in Shiny. And for the most part, these functions all end with the word input. There are some exceptions like action button, which is a button they can click, or action link, which is a link that they could click, or radio buttons. But for the most part, they end in input. The way that you call these functions is the same for all of them. There's some parallel syntax. You'll call the function, it'll have probably that input name, and then the first thing you give it is a name. The function is going to collect a value from the user, and you want to name that value so you can find it later. So here I'm going to call that value site, but I could have called it any character string I put in there. Next, these are all things that all these functions create an input object that the user sees, and it's very useful to label that object in some way that the user can read. So I'm putting cancer site here, so it will say cancer site above this drop-down menu. I could have said pick a site, pick a type, whatever you think resonates with the reader, this is your chance to give it to them. And then after those two things, the name of the value and the label, there'll be all sorts of arguments, but those will depend on what sort of input you're making. A drop-down menu will need a set of choices to have in the drop-down. A slider will need a max and a minimum value, and other things will need other things. The way to find out what you need is to open the help page for the function you're using, and then you could read all about it. All right, so if we come back here, just a quick quiz, because I think this is the most important thing to know. What did we name the value that the drop-down menu collects? You could underline that if you want. Site. That's important because that name is the connection to the recipe we'll use later that tells the server how to use that value. All right, perfect. All right, so you'll want to know where those are. Somehow I move my zoom annotation tool to the other side. Oh, you just drag and move it. Interesting. Okay. Clear drawings, boom. All right. Okay, so we named it site. When it comes time to write our recipes, we will find that there is a list called input. It's always called input. Shiny builds this list for us. And it adds each of the input values as an element of that list. And it gives the element the name that we chose for the value. So whenever I want to look up the site selection that the user gave me, I can find it as input $site. So you remember that list syntax we covered earlier? Here's us using it. And when the drop-down menu selects stomach, the value of input $site will return stomach. And if they change it to other site, it will return other site. It's always kept up to date with what the user is choosing. So that's great. Now I apologize here. In my first version of this course, I reserved the plot to be a second exercise. I don't think time-wise that makes sense, but just imagine the plots in these pictures too. Here's the rest of our app. These are the outputs. Let's look at how Shiny handles outputs. So if we come back over here to our code, one of the outputs we know is going to be a map. You don't know how to add maps, but looking at this code, do you think you could spot where Shiny is adding the map? Which line adds the map? Yeah, yeah, narrowing it down. So in this Shiny app, the AI puts some layout stuff in there. We're not really going to go over the layout stuff. It's obviously laying the app out in some columns. The columns have some widths and things are being collected inside of cards. It's pretty straightforward. I'll show you where you can go to learn more about that. But what really matters, what has to be there, is this leaflet output map function. Leaflet output is adding a space in the web page to put a leaflet plot. It's a function that's going to write the HTML that's necessary to have a leaflet plot in a web page. And that HTML is different than what's necessary to have a table or a regular plot or whatever. So it took a specific function to create this HTML that will host our leaflet plot. And this is kind of how Shiny works for us. It gives us a bunch of R functions that do all the HTML writing on the back end, so we don't have to learn HTML and JavaScript. Anyways, that function adds the leaflet output. It doesn't necessarily know how to make that output, but once we make the output, it will add it, insert it into the web page. And then further down below, we add the table with output table. And we'll add the plot with output plot. It's just not in this code. All right. Just like before, Shiny gives you a collection of output functions that all add different types of output. And then there's more output functions that come from other packages as well. And just like before, these all try to use the same syntax. So you always start with the function, which normally ends in output, just like input normally ends in input. And then you always first thing give it a name. This name is going to correspond with the recipe that we write later. So leaflets go put something named map in here. It looks like map is like a setting because this makes maps, but I could have named it Garrett's plot. But AI chose to name it map because AI is pretty straightforward. And then very rarely, some of these functions will take extra arguments that just help them do their job. And again, you could look those arguments up in their help page. All right. So we've laid out our app just by putting different functions into this UI section. We've named our outputs. These names are how the two parts of our app connect. So we always want to pay attention and use them thoughtfully. So we're going to be talking about a map and a table and a value called site. If you want to learn about the layout functions, this middle section here tells you all about it. You can also learn about the different components you could be adding on outputs or input side. You can even learn how to brand your Shiny apps pretty quickly and easily to look like they come from your institute or your company or whatnot. There's so much you could do in Shiny, but we're not going to cover all that. But you'll see most of the stuff that you can get to from that Shiny website. Instead, we're going to look at the other half of the app. And this is the server instructions. And those instructions are the recipes that explain how to build your things. You're going to need at least one recipe for each output in there because your app needs to know how to build that output. All right, so let's look at what this cookbook looks like. I've taken out a lot of code, so we just focus on the important parts. I guess I better check it on the chat. Roland, I see you asking about skills files. They're accessible on GitHub, and if you remind me at the end of the workshop, I'll show you that repo, and you could use them and provide other models and stuff too. They're all open source. And then thank you to everyone who's saying nice things on the way out. If you do have to leave early, I just encourage everybody to go watch the video and see how it ended. That will be available on the Iron Medicine website in a few days. Okay, so if you looked in the server section, you'll see it's kind of grouped into these different areas. There's probably one for chart in there that didn't add or plot. One of these areas is going to contain the recipe for map. I see people circling it already. If you don't know what it is, I want you to think about it this way. Which area would you want it to be? Because one day you're going to have to figure this out. Wouldn't it be nice if it's one called map? Well, it is. There are tutorials on the Shiny website, Jonathan. So those are the ones I recommend, yeah. All right. Let me clear, write some new circles. Which one do you think has the instructions for making the table? Yeah, output table. And then if we look at this, the actual code, so let me do everyone a favor, I'll clean this up. This is what it looks like. Output map is where we save the instructions for building map. Output table is where we save the instructions for building the table. And again, we're talking about lists and we're saving into specific elements of the list. And those elements are the names that we chose earlier. So when it comes time for our output functions like leaflet output to put a map in there, they're going to look at the output list and we're telling leaflet output to find the element named map. That was the first argument we gave it. It's going to look for output $map. And this is hopefully what it will find when it gets there. So the way we provide the recipes is we're just going to write the code that builds our map or builds our data table. That could be one line of code. It could be 20 lines of code. However much code it takes to build it, we're going to save that code so the server can have it to run later. But we're going to have to wrap that code up in a special way. And that's really crazy. That's where these render functions come in place. It's not enough to like take that code and just assign it with an arrow to that part of the list. R will try to run the code and assign the results to the list, but really we just want to collect that code as a recipe for the server to hold on to. And the render functions wrap that code up. The render functions are also matched to the type of object that that code creates. So there's a render leaflet function that wraps up code that ultimately spits out a leaflet object, and a render DT function that wraps up code that spits out a DT table object. Yeah, I'll get to the filter function in just a second. So the render syntax, when it comes time to write these render functions, the syntax is common across them all. You're going to save the results to that output list under the name that you told the output function to look for. You're going to save the results to your render function. It's probably going to start with render and underscore. The underlying name here, the blank here, is probably going to match the output function you used before. So we use leaflet outputs. Now we're doing render leaflet. They normally match, not always. And then inside of it, inside the parentheses and the braces, you put as much code as you need. Whatever you put in there becomes the recipe that the server gets to use. The server will pay attention to any reactive values that appear in that recipe. That's how it knows what to update when the user changes a value. It's only going to update the parts of the app that depend on that value, and it scans the recipes to see which values each output uses, and then it just takes care of the rest. It'll rerun that recipe whenever the value changes. When the recipe calls that value, it'll scoop up the newest version of the value, and you'll get some output, and it'll put the output into the web page. It works pretty satisfyingly. All right, where does that leave us? Okay, yes. So there's one other thing in here. It's filtered. Maybe type in the chat. What do you think filtered might give us? What is that doing in there? The data passed from the UI. That's right. That's exactly right, Jennifer. So let's look at it like this. Our Shiny app is organized like this. The drop-down menu filters our data set. The map plots that filtered data set. The table shows that filtered data set. The bar chart plots the filtered data set. You can imagine filtering that data set 3 different times, once for each of those pieces, and that'd be terribly inefficient. It's better to just filter the data set once and then pass that filtered data to the 3 pieces. And filtered is where we're doing that filtering. Not every Shiny app is organized this way to have something like this, but it is pretty common and you'll see it, so you should know about it. Filtered's a bit special because it uses this changing value from the user. And so you have to give it its own recipe. So Shiny can track when that value changes and knows to update filter and do it. And the way you do that is by wrapping its recipe in reactive. Reactive is how you create what we call a reactive expression. It's something that relies on reactive values, but it doesn't appear in the output in the UI. It's purely server-side, something that everything else will use. And then when other things use it, they call it as a function. It's the syntax for it. I like to think of it as this. When create instant map calls the filtered function, then filtered runs this here. And that's how it picks up the most fresh value of input site, because when it runs a function, it looks up input site. But Shiny also knows that if create instant map is using filtered, then that means it's also relying on the reactive values that filter has in it. And so it knows that when this value changes, create instant map needs to be updated as well, because ultimately it's relying on that value. Same with data table down here. So I hope that made sense, but just a quick explanation of how this app is organized. All right, so let's finish that. We already finished that, but our code did this. And that's all right. So here's what we have right now. We have this Shiny app. Hopefully you've seen it, you've played with it on your screen. If you want it, just copy and paste the code from solutions03.app.r. And it's a really cool Shiny app. You could push that to Connect, it'd be great. But we're going to take it a step further. We want to replace that drop-down menu with a chat bot powered by an AI, LLM. So our users could just chat with our app and ask it interesting questions that would be really hard to ask through any combination of drop-down menus. And the package that's going to let us do that is called QueryChat. But before we get there, maybe go switch that out. Let's just summarize what we saw in Shiny. Shiny apps, I say they're just R or Python in that you only need to know how to write R or Python code to use them. They do all the JavaScript, HTML, and all that stuff under the hood. Go to shiny.posit.co to learn how to use these or to find tutorials on them, that sort of thing. And then build with that Shiny. You could ignore that. That was an artifact of how we used to do AI. All right. Let's talk about the QueryChat package. This is the last thing we're going to do today, but also the most impressive. It is a package of R functions that help you add chatbots to your Shiny apps. And it's not terribly hard to use. All right. So this is what a Shiny app might look like that has a query chat. It has a place where you could ask the app questions and it will print out the answers for you. Sometimes it'll suggest questions for you to ask, and sometimes it'll show you the code that it's running to give you the answers. It can also generally update the rest of the app for you based on what you're asking it. Just like everything, it has its own documentation, and this is the webpage for QueryChat. I'll also put these links up at the end of the webinar so you could catch them then. But the way QueryChat works, I think, is really elegant. And it gives you reason to trust your Shiny app and for things to work out well. When you set your app up to use QueryChat, it's going to, one, connect to some sort of large language model like Claude Sonnet or whatever. So when people ask it questions, it can pass the queries on to the model and get the responses and bring them back. But it's been designed to ask that model to write SQL code to answer the query. So the model will give back SQL code. AI is really good at writing SQL code. It's probably the most documented language out there. So generally, the SQL code will work. QueryChat, the package, separate from the AI, is going to take your table of data and put it in an on-disk database made either with DuckDB or RSQLite. These are packages that make on-disk databases. The QueryChat loads them when you load QueryChat. So your data is essentially in a database next to your app. When QueryChat gets SQL from the LLM, it gives it to the database. The database runs the SQL on the data set to do the filtering, and then it returns that data set, which the rest of your app can then depend on and use. So the LLM never touches the data, doesn't do any of the filtering itself, it just writes SQL code, which it's good at. The database runs the SQL code, which it's good at, and the Shiny app just uses the results. QueryChat does give the LLM the name of your table and the name of the columns in the table because the SQL queries will use that information, but it doesn't give you the raw values. But again, this is not a security guarantee because QueryChat can also query the data and compute things like means and medians and see elements of your data. So it's not a blanket security statement, but it allows us to do these things. We could trust that's reliable. The database will run the queries. If they don't work, it'll ask the LLM to rewrite the query. So it weeds out hallucinations as you go. It's safe in that QueryChat does not allow the LLM to run any queries that would delete the data. But even if it did, this is just a temporary file that we made to support the Shiny app. And the next time you open the Shiny app, it'll be remade. So not much is lost. And then it's reproducible in that you can access the SQL code that's going to write and save it. And it's semi-private in that you're not necessarily just sharing all your data with the LLM. The real takeaway from that is it saves tokens because you don't have to show the data. And yes, I'm realizing now there was a question back there about why it filtered it with base R code. The AI made that decision, Jonathan, or whoever was asking that. You could also do it with a pipe and with filter. I ran with that decision because then I didn't have to have a line to load the dplyr package, and it's easier to concisely show everything on the screen there. But both of them would work. All right. Okay, so this is what the QueryChat documentation looks like. I'm just showing you this to let you know there's a lot of articles on the QueryChat page that cover everything we're going to do today. So if you want to go back and read at your own pace, you could follow along there. All right. Now, the trick for QueryChat is setting up a large language model for it to work with. And we're going to do that through environment variables. And we're going to set it up in this today to use an Anthropic API key, but you could do it with other models too. And QueryChat will look for an environment variable, a variable that exists in your R session called QueryChat_client. That variable tells it which model provider to use and then which model to use in this format. Anthropic will be our model provider. Claude Sonnet 4.5 or whatever will be the model it uses. Now, of course, we can't just point it at a model provider and expect the model provider to start giving us service. We have to prove that we have an account with them. And we do that by setting some variable. It depends, honestly, on the model you're using. Anthropic just asks for a straightforward API key called Anthropic API key. GitHub Copilot wants you to supply a GitHub pat. Amazon wants you to do some Amazon stuff. I'll show you where to look all this up, but first we're going to do it with Anthropic because it's straightforward and we'll see how it works. Setting environment variables is a little tricky. I'm not sure if you've done it before in R. You can easily set environment variables in your R session, but it's tricky because we're going to make a Shiny app. And when you launch a Shiny app, it opens in its own R session. You want to set the variables in that session. But the whole reason people use environment variables is they're a way to supply secret information that you don't have to save in your code files. Shiny's go run all our code files and we could use those to set up our environment, but then our secret information, our Anthropic API key will be saved in that code. And if we accidentally check into GitHub or something, that would be disastrous. I can tell you from personal experience, as soon as an Anthropic API key gets on GitHub, it stops working because Anthropic's scanning it. And that's really hard to debug in the middle of a workshop. So we're not going to let that happen. Instead, we're going to use the best practice for setting environment variables in R, and that is with a hidden file called .renviron. You may or may not know, but whenever you launch a new R session, it will scan your directory of your computer to see if you have a .renviron file. This is just an R script, and actually, I don't think it's R script. I think it's a bash script. That R will run at the start of the session. And this is what people use to set up environment variables like passwords and stuff that will then be available for them every time they start an R session. Opening up a hidden file on your computer can be a little frustrating depending on the computer you have, but there is this function from the use this package called edit_r_environ, which opens the file for you. It's quite terrific. I love it. It works on every operating system. It's not promising. I guess Is this really true? Okay, I've been kicked out of Posit Workbench, probably because I've been on here for too long idle, but if this is you too, do log back in. Be sure to use the bottom image. I'll launch that. All right, so I'll keep talking about this while that's loading because we're in the final 15 minutes. I'm going to use this to open up an R file, and then I'm going to save into the R environment file the information that sets up what QueryChat needs to know. It'll be these two lines down here. We're just going to copy and paste it into our file, and we'll save our file. It only takes effect when you start a new session, so it wouldn't be available in your session unless you refresh R, but when you start a Shiny app, it'll be available in that session, and that's what we're doing. Let's see how this is coming. Perfect. Well, almost perfect. I'll let that continue to load. I'll just close these ones here. Back to the slides. All right, so we'll do that. But while we're waiting to set it up, let's talk about what QueryChat's going to do to change our app to make this chatbot appear. There's a file over in the solutions. Actually, it's probably 04 QueryChat. I'll fix all this before we provide the slides. It looks like what's on the right-hand side. Our regular file looks like what is on the left-hand side. And there's only 3 changes here, one in the UI and two setting up the app that we need to make to use QueryChat. So see if you could spot them. If you can, underline them so we could take a look and see what they are, and then I'll tell you what they do. Yeah, so sidebar QueryChat, that's a big one. Library QueryChat. So you found all 3. That's perfect. We're going to use functions from the QueryChat package. So we have to add it with library. So that just makes those functions available. Second, this QueryChat QC function is the workhorse of QueryChat. The way that works is you call it on the table that you want the LLM to work with. At the moment, QueryChat just works with one table at a time. So you give it a table, and that's the table it can filter and query and ask questions of. You can also give it a greetings, and that will just be a message that appears in your app when a user first logs in. So, you see a chat bot, normally it says something to you. You get to decide what it says to you. But the important component of this is that you save its output to an object because it gives you back a list of useful things. You want to save that list and you go call the elements of it throughout your app. Let's get that. All right. What's in that list? Well, first there's a sidebar, which is just all the UI you need to put that chatbot sidebar into your app. It's just bundles it all together for you. If you don't want it to be in the sidebar, it also gives you QC UI, which you could put in other places. We're not going to use that today. And then it gives you QC server, which is something that will help you set up the server side. I'm going to come over here and show you that we're using QC sidebar to make our QueryChat sidebar. So whereas before, I could use this too, we had to write all this stuff to make a sidebar and put a drop-down menu in there. All that's gone. We just set sidebar equal to QC sidebar, and we'll be taken care of there. All right, let me just pop in over here. Okay, good. I'm back. The code we're looking at is 04 QueryChat, but it's all in here. And you can see QueryChat, and you can see QC sidebar. All right, so we'll come back over here. On the server side, we need to do a couple things. There's just two things I want to see. Can you spot the two changes on the server side? There they are. Thank you, everybody. The way our app was set up with this reactive value actually makes it really easy to work with QueryChat, because QueryChat is kind of a Pareto case situation. You could use other tools to do all sorts of specific things with your AI, and I will show you the package to do it, but I'm not going to teach you how to do any of it today. QueryChat does one specific thing. It takes the data and it filters it. It'll answer questions about data, but ultimately what it turns back to the app is just filtered data, which means having this reactive expression that just returns filtered data is the perfect setup for using QueryChat, because instead of doing the filtering manually, we could just give it the data frame that QueryChat returns. But where did that come from? Well, over here, this QC server, it itself returns another list. So I'm saving the list that it returns. I'm going to have to call it in the server and get that list. And inside that list are three things. DF, which is the data frame of filtered data. And that's why I'm passing into my filtered thing. So let's just go pass forward this filtered data frame to everything expecting it. I'm not using in this app, but I could also get the SQL that the app wrote. This isn't really to run the SQL. QueryChat's going to be running it, but it's to display the SQL so your user could copy and paste it if they wanted to. And then title is a little interesting. If you have a plot or a table and you want the title to change to sort of suggest what sort of filtering's happened, well, this is going to be a character string that the model made that tries to create the sort of filter the user asked for. So it's something that would be appropriate to put above the title of that filtered, the plot of that filtered data. We're just going to use the actual filtered data here. So we'll use this, and going backwards, here's where they appear. I'm calling the server, I'm collecting the list of reactive outputs it gives me, and then inside this filtered data set, I'm just giving it the QueryChat filtered data. And there we are. So those are the only differences you'll see in your code files. Now, let me demonstrate the use this thing to make this work. So cleaning up my page just a little bit. I'm going to copy all of this into my app. So ta-da! Oh, ta-da! I now have a QueryChat app. I just updated it, and I could run that app too. And that app should load, and it might look like a functioning app. But if I try to use the chatbot here, I don't think it's going to do anything because I have a fresh account. So let's see. Show me the mail cases. Okay, I would be surprised if this worked. It's just go continue forever because there's no model set up for it to talk to on the back end, because I have to set those environment variables that it's trying to look for to get the model. So that's not working. So I'm going to stop that, and I'm going to set up those variables. Now, the way I suggested we do this is with that function from the use this package. I'll come back up to my R session here. I'm going to use this syntax where I type use this : that means I'm asking to run a function that lives in the use this package. If I just ran library use this, I wouldn't have to do that, but right. Then I'm going to type in edit R in, I kind of expected tab complete help me out by now. Edit R environ. So it's running that. And this is what that function does. It just finds this hidden file on your computer and opens it so you can manipulate it, edit it. What I suggest, since we have 5 minutes left, is don't do this. Let me do this. I'll have you do it on the connect side in a second. Not sure if that'll work, but we'll try it out. So what I would have done for this file is come back here. Just want to copy and paste this code out of here. This is what it might look like for you if you're setting something like this up. You just paste it in here. So every time R starts, it's first going to save a value here and save a value here. This is an Anthropic API key that's working for us today. We could all use it. And if I save that, then if I click this button to refresh my R session, it'll start a new R session, but it'll run this file before it starts. So there it restarted. And there's a function called sys.getEnv where you could get the values of environment variables. And so I'll just type in QueryChat client to see if there's a value saved under this. And there is. It's what's in my R profile. So now if I run this app again, it should work with those values. Here's a situation where I never really stop the things. I'm going to stop it. All right, I'm going to stop it there too. Whatever, I don't want to get into all that. I'm going to delete this console because I want to make sure that I'm getting a new R session when I run this app. And now if I ask it something like, show me only cancers of the digestive tract. Actually, the server got closed. What am I doing? Okay, so I can't see what that message was about, but you could see now that it is talking to a model. And gosh, Zoom just landed right in front of the chat window so I could get to it. And so it's filtered the data down to these types of cancers because the AI decided they were related to the digestive tract. It's giving me suggestions what I might want to do next. So maybe I want to see the total number of cases. This is an example of QueryChat querying the data. So it's not going to return a filter. It's just in the chat going to tell me how many digestive tract cases are. I could look at this to see the SQL that it ran to tell me that. And up above, it shows me the SQL it used to filter that data. All right, so since there's only a few minutes left, I'm not going to have you publish your app to Connect, but I will publish this one so we can see what it looks like. First, let's stop this. Second, let's click that button to publish the app. And let's just accept everything real fast. And then let me make sure the helper files are published with it. I'm going to deploy my project. Now, why are we doing this? Because if you publish a QueryChat app, you have to go to Connect and provide those environment variables so the app can find the LLM from over there as well. And I'll show you how to do that. Connect allows you to save environment variables in such a way that once they're saved, they'll be used until someone overwrites them, but no one can ever get them back out again, which makes them secure. And certainly not your users. Your collaborators can rewrite the values, overwrite the values, but even they can't get them back out. All right, so that's on Connect. I'll open it up. Here's my app. It's going to load, but it's not going to work because it's not connected to a model. If I go to Settings under Advanced, I can create as many environment variables as I want. I just add new variables. I have to give them a name and a value. So I will come back here. Do I still have our environment? I'll come back here. The name of this first one will be QueryChat Client. Put it there. The name of its value will be a test of where my stuff is. Where am I? Oh, be this. So you don't use quotation marks. Passing that through. Then I'm going to add a second value here, and it'll just be the other one. And then we'll be good to go. The Anthropic API key. Go add that. The value will be this. I'm going to add that. Add that, and then down at the bottom, you can save it. Okay, so now we reload the app. It'll be a complete app and it should work. I'm going to paste those values into the chat for you all because we are coming to an end, but the server will be up for the rest of the day and these things will work. So if anyone wants to, to keep trying it, make sure you copy and paste this right now so you have it, but then you can use that to try to get your QueryChat app to work from whatever. Now that API key is not going to work forever, but it will work this afternoon. Okay, getting back over here. So now that this is up, I'm going to close this. By the way, if you want to see who's using your apps, there's a usage tab. So that's cool to find out. Anyways, show me mail cases. If it does something, we've finished the workshop. There it goes. It's off and it's running. And we now have a QueryChat that anyone who visits the URL for this app and we gave access to can now start talking to that AI. It'll be built to our account, but they'll never have the password or anything for that account. And they can explore the data. So what does this all mean for us? At the end of the day, here's 3 things I want you to know. You could probably remember what we did. I'll come back to the slide. These are the links for what we covered if you want to go deeper. Posit does have an academy now that you can visit to learn things. There will be some Shiny tutorials coming up there. This is where we're going to start investing in our tutorials. And then if you like all this sort of thing, you want to go deeper and learn how to do more and more with AI, check out the Elmer package next. That's the rest of the Pareto rule, the 20% that lets you do whatever you want, whereas QueryChat is the easy part that lets you do 80%. All right, so let's stop on this slide. So if you want to take a screenshot of it, go ahead. And I'll stick around for as long as R Medicine lets me. They've already been generous by giving me 2 extra minutes, but we're finished. Thank you everyone for sticking through to the end. I hope you found this interesting. I'll turn it over to you, Jesse.
Garrett, that was a real tour de force. It's nice just living in the IDE and going through step by step. Really appreciate the time. Yeah, this is a part of the R Consortium series of webinars and workshops. Please check out the R Consortium site. Also, Posit providing this fantastic information. Posit's a member of the R Consortium, and they're endlessly energetic and supportive, and we very much appreciate that. And this is also part of R Medicine, which just concluded this year, but is an annual event. It's a 4-day series of workshops, demos, lightning talks. It's really something. Those videos are going up on the R Consortium YouTube site. Most of them are already up there. There's just a few last ones. So we have Emily on the call as well. Emma, if you want to just say a last word about R Medicine. But anyway, Garrett, thank you. And people who have spent the time and energy, thank you so much.
Yeah, Garrett, thank you so much. This was a wonderful workshop, and thank you to everyone for coming today and those who stuck around to the end, and the rest can check out the video, which will be up on the R Consortium website after the fact. And for everyone else, make sure to check out the R Medicine conference next year, around the same time as it was this year in May, maybe the first-ish week in May next year.
Okay, thanks very much, everyone. Take care.
Thank you, everybody.